Okay, lads, can you all see the screen?
We can.
Yep, sure.
Okay, so we're going to start with a bit of sadness. So please bear with me. So as I said, Paul Skyrme passed away just over a year ago now from stage 4 cancer. And I would like to consider him, and I'm reading from a sheet, by the way, because otherwise I won't get through this. So Paul was what I would consider not a legend, but an icon of the industry. He was a founder of E5. He was what we called the technical one. So for people who think I'm smart, I always go, ha, have you met John Ward or David Watts? And then these guys would go, ha, have you met Paul Skyrme? So you always surround yourself with people who inspire you and who are better, who you believe are more intelligent than you are. Paul Skyrme was, well, he's a qualified electrician. He did an electrical apprenticeship, mechanical apprenticeship. He was an expert in machinery controls, and he was also an EMC expert. And he sat on various technical committees for that. His passion for this trade and his family was off the charts. And the most heartbreaking part of speaking about Paul is Paul had such an impact on industry, but most people in industry will never know the impact he had. He wasn't a influencer, he wasn't a YouTuber, he wasn't a social media darling. He was a darling, but not a social media darling. His product knowledge was second to none. He could often be found debating what we loved and we still use in most meetings, the essential health and safety requirements of the European directives. His knowledge of CE marking of products was probably better than most people in trading standards. He spent, just for fun, loads of time on multiple chat boards advising electricians, engineers, and end users. His passion for getting it right led to his famous phrase of no, 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 which you knew you were in for a bollocking or a re-chipping. And that was fantastic. Paul, whilst dying of his terrible disease, attained IET fellowship. He was an active volunteer to the point where literally months before he died, he'd lost his voice, and yet he dragged me along to an event where I was doing the talking and he was still trying to chip in, which is just amazing for his local IET network. And he would help anyone who needed him. And just a couple of memories for me. I remember sitting in a hotel at 2 a.m. in the morning, and we'd finish going to an event and he'd sit down, he'd go, here's 50 IET membership applications he'd want to go through with me. And we'd go through all of them. During his illness and even before, he got onto Discord, Dave's one, Sparky Ninja one. Please go onto it. Mentoring people, helping people solve challenges. And if you want to know more about him, you can listen to him on our YouTube channel, his cancer episode. You can read his articles in the Foothold website, which is the IT charity who supported him, PE magazine. He has produced multiple articles, some which have changed the wiring regulations and guided it. He's written guidance notes for machinery. He was a husband to his beloved wife, Yvonne, a very proud father to his girls, Emma and Sophie, and his son, Jamie. He was a father-in-law to Liam and Joseph. Well, I say was, he still is, even though he's not physically here. Spiritually, he's very much here. A granddad to Olivia and Amber, an uncle to Brandon, and a very, very, very well-respected member of his community in Swansea, and as well as a very well-respected peer to many industry experts, including those at the IET. Probably worth noting as well, he was, for a year or so, the IET technical helpline. So while he had cancer, he was working doing IET technical helpline. The man's commitment was phenomenal. Yeah, my words are not doing him justice. I constantly said this, and I'll say it again. Good people like Paul are never gone until the last person who loved them is also gone. So Paul will be here for years, and I'll explain that on the slides in a moment. That's that. So we probably should get started now. If I can work this machine. If it works. There we go. Okay. Requirements for electrical installations, IET Wiring Regulations 18th edition Amendment 4. And on the screen there is a picture of the Simpsons character Mr. Skyrme. Now, just to be clear here, that image will turn up randomly on podcasts and webinars for as long as I draw breath. It's as simple as that. And it would be the same if Dave passed away or John passed away or Ryan or Dan randomly pop up, just to get that person back into the hearts and minds of people and to know that they're a driving force behind some of the stuff that we do.
Yeah. Fundamentally, his training he gave us in our logical thinking and our processes, and the way that we would look deeper into things, is the way we've programmed ourselves to think and to learn and to produce this kind of stuff. In our professional world as well. So he's always still with us.
I think it's fair to say, Mr. Berridge would probably say this better than me.
Oh yeah.
His brain certainly is not dead.
Mm-hmm.
In no way, shape, or form. His brain is not dead. And I think maybe at some point we will do a podcast about Paul. Maybe Dave will review some of the papers that he wrote while we're doing that podcast.
Yeah, can do.
It'll be a good talking piece to keep it technical, because that's how he is. Now, on to the next slide. So this is kind of that whole indemnity. Now, I think it's fair to say over the years, we may have been criticised once or twice, and we may have been critical of things and organisations. And that's okay, because we're a free democratic society. As long as you don't slander or go for the giblets, you can have an opinion. This entire piece, as with most of our podcasts, are opinion pieces. They're my opinions in a personal manner, not my employers. Same with John, same with Dave. We are not psychics. However, this is my bit to do what is known as the Crichton moment. So those who've seen Red Dwarf remember an episode where Crichton went, smug mode. So we're not saying we're psychics, but as we've said repeatedly on this journey, if you want to know what's coming, it's not hard to find out. And it's fair to say that some of the stuff that is starting to creep in, you can look at webinars we did 5 years ago to see us predicting like the POE stuff, Dave. Perfect example. We predicted this. Not saying we as in our idea. Yeah. But guys, if we can do it, you can do it. And one of the things that I really want to encourage, which is why we don't do as many of these, is other people to pick up that baton and do their own opinion pieces and do the research, so that more independent voices are questioning. At the end of the day, I think that's a really important thing to do. Right, now we'll get started. Okay, so excuse me. We are coming up to Amendment 4, so we've broken the mold. So this week it was released on Wednesday. I believe you'll be listening to this on YouTube on a Sunday. The IET did a quick fire, really good roundup of stuff with a nice couch and set, and very well produced. We're not very well produced, it's just our backgrounds. But they have broke the mold, because there was always that presumption of you do 3 and then you reset. However, rightly so, the BSENs, they do multiple amendments into the teens, if not further. And also, one of the valid points was the ISO standards. They do 3 and then they do a full revision. Doesn't necessarily apply here. So they've decided to go into Amendment 4. So, hey, maybe the 18th edition will be around for the rest of our careers.
It does kind of bring the question as what actually does it take for it have to become a new version then? You know,
I would like to say I know.
Yeah.
Okay. John?
Yeah, I mean, it's, although we've not had an Amendment 4 in the past, we have actually had the 16th edition actually had 5 amendments, but they actually renamed it halfway through, because that's when it became BS 7671. So there was the 16th, and they had amendments 1, 2, and 3, and then they changed it to BS 7671, and that had amendments number 1 and 2.
Okay.
So in effect, there was 5, but they weren't called 4 and 5. It went back to 1 because they changed the title of the book, but it was still the 16th edition the whole way through, and that went from 91 right through to 2008. So that lasted a very long time. So it's not totally without precedent, but it is the first one that's going to have actual Amendment 4 on the cover.
So I will put in the links the link to the IET event. I know the IET have done one. I think CEF did one, but I don't know if they've got a YouTube channel. It may have just been on LinkedIn. I know NAPIT and the ECA are going to do one as well, which is great. Lots of people have different opinions on stuff. This is kind of interesting. So everybody's familiar with the slides that they're seeing because we usually use the black background, nice on the eyes and stuff like that. But it's quite interesting when you look at 767 18th edition, first release 2018, as we know. But then there was a corrigendum, and then there was Amendment 1, then a corrigendum to Amendment 1, then Amendment 2, then a corrigendum to Amendment 2, and then Amendment 3 literally last week with 1 regulation and 2 definitions. And now we're heading towards Amendment 4. Now, from what we see in the DPC, the issue date is potentially the 17th of April 2016. 2016? Sorry, 2026. I am so stuck in the 90s, it's mind-blowing, or the 80s if you look behind me. Again, visuals, I'm a visual learner. This is how I kind of see stuff. So normally, as in last webinars, we go from left to right, the blue book, the white one, because it was digital, then to the brown, and then to the white. Now it's quite interesting when you slot the corrigendums in, quite a lot there. It's been quite busy. And I think on one of the webinars, one of the questions answered was Amendment 4 was in theory going to be Amendment 2, but 722, which was Amendment 1, that got rushed. So it's a digital free copy. Amendment 2 was a bigger mop-up. Amendment 3, again, a rushed one for this bi-directional stuff. And there have been corrigendums. I do remember in the good old days, you used to say a corrigendum was a way of correcting an error, but we seem to be marketing and spinning it into something. No, it's an opportunity to improve. Okay, all right, well, yeah. But the good news is we've got plenty of time to think about it and comment. And the most important part of this, the reason why we're doing this, is because we want you to get so annoyed and riled up that you will go and actually comment on the darn thing. So the DPC, obviously it's out now, 8 parts again, 673 pages. That will change because obviously it's got deleted bits. It may go up, it may go down, we don't know. But let's start with some random things. So there are hundreds of changes in this document, hundreds. And the webinar so far, there is nowhere they could go in it, but hey, us being sad, let's go through as many as we can. Quick one that kills off loads. The use of the term IET, initials, has now been replaced in every part with the Institute of Engineering and Technology. So rather than an abbreviation, they've spelt the whole thing. Which I did see a really good post the other day on the IET where it said the Institute of Everything Trendy, which I quite liked. The notes in the document say it may be implemented immediately. Okay, well, yeah, of course, the minute it comes out, you can implement it immediately. I don't know if there's a transition period yet. Guys, jump in if you know that. Other minor changes, but hundreds of them. Note in lowercase is now note in uppercase. Okay, yeah.
Yeah. It's these are just silly little things, but it does make a huge.
There's loads of them.
When you scan through the document looking for those little lines that show what's different, you end up seeing an awful lot of these that are just little changes like that, which is it's why the summary of changes is so useful.
Well, I would like to congratulate the guys because it confused me when I was looking at the lines as to what has changed. But also, weird one, page numbering, John.
Yeah, it's in 2 PDFs, and the actual page numbering of on the printed pages or the actual bits you read, there's some gaps which seems a bit weird, and then there's some which are not quite in the right sequence. So obviously it is only a draft, but you would expect page numbers to be in a consecutive order, wouldn't you, normally in a document? But in this case, they're not. So how bizarre.
I bet it was you who found that, John, wasn't it?
Yeah.
Yeah.
So yeah.
Well, no, actually, it was him.
I was going to say, I wouldn't even think to look for that.
So I mean, it doesn't really affect anything, but it's just another minor item there. And there's also other things like that, as well as just capitalizing whole words. They've sort of put a little full stop after certain things and put a capital where it wasn't before, and this sort of thing. So
they've done a bit of the Americanizing as well, with like putting the Z in instead of the S's in harmonize or standardize and stuff. I remember.
Yes, they've got American.
I remember Paul, Mr. Skyrme, shouting about that happening in these standards, and he said that back then it'll happen soon enough.
Yeah, it is. It's going American. I think they're just using spell checker if it's set to English, American English. Other thing, obviously, comments. The reason we're doing this, we want you to be enthralled or enthused sufficiently to want to go online, I'll put the link in the YouTube comments and just Google it, guys. One thing I get a lot of questions, where can I find this? Google. Everything's available on Google. Just type it into your phone. But please comment. I think on the last amendment, there was about 3,500 comments. If we can get that to 10,000, that would be fantastic.
I love you.
Well, I'm just to be clear, if I was on the committee, I wouldn't care, because the more people who commented, the more I would realise that I am doing a public service to the people in my trade, and I'm representing them. But anyway, let's get into part one. So one of the first regulation, it's not a change, it's an addition of a note. So it's 1326. Part one's my favourite bit, fundamental principles and all that. The cross-sectional area for conductors shall be determined for both normal conditions and where appropriate fault. That's fine. That's why we do adiabatics and all that good stuff. But there is a note at the bottom that says the items listed above concern primarily the safety of electrical installations. Cross-sectional areas greater than those required for safety can be desirable for economic operation. What do you think of that one?
Yeah, no, this is quite odd, because it's sort of hinting along the lines of energy efficiency and all that sort of thing. And as we'll see later, a whole load of stuff about energy efficiency has disappeared. So on the one hand, yes, it's coming in, but on the other hand, it's leaving us.
So is it fair to say, because that to me says very clearly, you might want to go from a 1 mil or a 1.5 lighting circuit to a 2 mil, to reduce your losses, which then ties in with the whole 60364-8-1 energy efficiency of electrical installations, which talks about larger cross-sectional area of conductors reduces losses, which then gives you the energy efficiency. It also introduced the role of an energy manager, and also being able to do energy efficiency assessments of fixed installations. And when you read it, you just go, great, we're now doing an EPC on the wiring. Now, given the rush to net zero, and I'm not a politician, given the rush to net zero, I see enough of their work. I'm telling you now, I'm predicting it here, that in 10 years' time, by 2034, we will be talking about EPCs for wiring, larger cross-section area conductors, period, because this stuff gets sewed in and taken out and sewed in and taken out. But in 10 years' time, we're going to realise we're nowhere net zero. Someone in government's going to speak to the IET, and the IET are going to get told, put it all back in.
It's going to have to, because again, I've just finished studying sustainability, and the biggest culprits to that is travel and energy and power, and the use of energy and power, and a huge amount of energy is lost in heat. Huge amount of energy is lost in heat. So the way that we can design fixes for that, other than suitable load selections, is increasing our cable sizing to lower our heat losses.
So, folks, if you've got a means to set up a copper manufacturing company and watch the money roll in.
Let's just add the caveat to this, though, that just adding a bigger cable size will then mean you have to redo calculations, because you'll have higher fault currents, you'll have higher thermal constraint challenges. So there's always a knock-on effect to it. But fun.
Yeah, it's an interesting one. So that's kind of, we're not going to go through every single change, although we're going to try and get through as many as we can. And we may do this again, maybe in a couple of months' time, because there is a 3-month window to do comments. So it might be worthwhile if we get asked to maybe expand on some stuff. So let us know in the comment things down below if you're on the world of YouTube. I don't know if you can comment on the audio one. Pass. I got back into Spotify, but I don't know.
You can with Spotify. You can upload a video and you can add commenting on it as an option. If it's not set up, I'll have a look for you.
Oh, can you? Oh,
no.
I've learned something new today. 13312, selection of electrical equipment general. Now, where there are no applicable standards in existing regulation, obviously, the item of equipment concerned should be selected by special agreement between the person specifying the installation and the installer. Now, this for me is, I love this when this came in, because there's lots of stuff that is installed as part of an electrical installation, especially industrial, that doesn't have a product standard. In fact, dare we say, EV?
Oh, EV's filled with it.
Did I just swear?
Yes, you did.
I did. I just swore. Apologies. But there is an additional note that says such use shall be recorded on the appropriate electrical certification specified in Part 6. I didn't think that was new. I could have swore. And again, maybe I'm getting regs blindness.
I think
wasn't that in there somewhere before?
Well, we did have in 710, we had that bit where it talked about compliance with standards under the protective requirements of a TN system, and it said that if we could include the declaration, all the information, it wouldn't become a departure if we did all that work. And I think what this is doing is it's kind of bringing that as a general thing, where we can add details and information or anything that isn't compliant into the certificate, as a general approach.
Well, me and John agreed. If Elmo can't understand it, no one will.
Yeah.
But yeah, it really is interesting. I mean, I've had like variable speed drives, PLCs, bespoke built panels, no product standard as such, although individual type tested, but the assembly isn't tested. We've now got ES1, which came out in draft. Google that, folks, which is the IET's attempt at the EV product standard. In the absence of nothing, something is better. Although I think there's probably going to be quite a bit of debate as to how that works and how that looks like, because the draft like opened and closed, and I'm sure there's probably going to be quite a long debate over how that gets fine-tuned. So yeah, 132. Now that's pretty much the only real changes of anything that we saw of relevance in part 1, especially of note. Now part 2, loads and loads of stuff. Now normally what we do is just list these as a bullet point, but we thought we'd talk through them because it's quite a lot. So we'll start off with some new definitions that are in part 2. Access network, which is defined as functional elements, equipment and infrastructure that enable communication between the core network and a customer network. Now straight away my brain says to me, why is IT stuff going in the wiring regulations? I don't work for IT. I'm not switching it on and off again, but this is potentially where we are, folks. We said this in podcast years ago, that electricians are now going to have to understand data and software and hardware.
Well, we have said before, though, even on previous, that it's always been within the scope. Telecommunications and system circuits have always been in the scope of 7671 because the way it impacts the system, it's electrical infrastructure. Whilst the fundamental principles may not in certain fashions be the same, the installation of it can impact the property and all that stuff. So it's just going to expand. It's just going to expand and expand.
Well, we've got balanced cable, which is cable consisting of one or more symmetrical metallic cable elements, twisted pairs or quads, right? Cat 5, Cat 6, basically. Battery. I swore battery was defined in here before. One or more cells fitted with necessary for use. For example, case, terminals, marking, and protective devices. Yeah, okay.
Yeah, it's a bit of a weird way of writing it, but basically a cell is the individual element, and a battery is an assembly of those into a single unit. So that's the main difference.
Yeah,
there's me thinking I'm going absolutely bonkers. It's
a bit like
Duracells to make a bigger Duracell.
It's a bit like how I think about a PV panel being a series connection of cells connected in a parallel arrangement to create one output. And then we connect all of them together to create a much bigger output. It's the same kind of principle.
For those watching on YouTube, apologies. There's not that many images in this one just because we didn't have time. One other definition that's in here: bidirectional protective device. Amendment 3. Protective device where power supply may be connected to either set of connection terminals and power flow may be in either direction. Note: a bidirectional protective device is not marked for power flow direction.
Yep, except of course when it is, because it was an old one that did comply, and now they haven't actually updated the labelling on the product. But yes.
Watch our previous video for more on that from John.
Let's just remember and remind everyone listening, this is our opinion. Best of luck to everyone. Right, capacity of a cell or battery, quantity of electricity static charge for which a fully charged cell or battery can deliver under specified conditions. So you can see all this modern text in here. Note 1, capacity varies with age, ambient temperature range, and or the number of rate or charge-discharge cycles. Note 2, capacity is usually expressed in ampere hour or kilowatt hour. I do wish we'd just pick one.
Yeah, I
Yeah.
agree.
Get on with it. I
It should
really,
be kilowatt hour, really, but there we go.
Well, say that to the automotive industry. How dare you, John Ward? Anyway, note 3, usable battery capacity describes the expected battery capacity under a range of operational conditions, including ambient temperature and lifespan, as specified by the battery manufacturer. John, you'll know about that, Mr. EV.
Yeah, the big thing there is ambient temperature, because the actual temperature of the battery itself has a massive impact on what its capacity is. And generally, if it's colder, the capacity goes down a lot, which is why a lot of electric vehicles, if you use them in the winter, you'll get sort of 20, 30, 40% less range out of it than you would in the middle of the summer, purely because of the temperature. And that's also why some electric vehicles have heaters in the battery pack to heat them up so it can actually work better in cold weather. So you plug it into charge and it will heat up the battery first, and then it will start charging the battery after it's been heating up for 20 minutes, just because it works better that way. So it's easier to waste a bit of energy heating it up, because then you can get more in it after you've done that. So
I'm not going to comment on EVs. I don't have one, so best of luck to anyone who does. A cell, a basic functional unit consisting of assembly of electrodes, electrolyte container, terminals, and usually separators that is a source of electrical energy obtained by direct conversion of chemical energy. There's some. I'm actually kind of pleased this stuff's coming in, but I do think our maturity as an industry, it's a long way to go. But I'm pleased this is coming
I think
in.
a lot of us is going to listen to these words and go, okay, then. I don't think we're going to really be given an opportunity to develop a bigger understanding on battery technologies or anything, not to the terms that it's using here.
But the thing is, Dave, I think this is a matter of eat, sleep, repeat. So for me, these are not terms that are in my vocabulary all the time.
No.
But like with anything, over time it does soak in. It will come, but you just got to do the work. Connecting hardware is a new term, a device or combination of devices used to connect cables or cable elements. Fairly simple. Core network, functional elements of equipment and infrastructure that enable communication between operator sites and on network data centers. So you can really see this whole smart connectivity thing coming in. Diversity. Has this been redefined, John, or is this a new definition?
it's listed in there as a new one. Although,
means of determining maximum demand for an installation or part thereof, taking into account usage patterns. I think that's been reworded, because taking into account usage patterns doesn't ring a bell. Maybe Dave, you can have a quick look at see if it's in the current.
I'm just going through the current now. It's
Okay.
not in the current.
Right. Well, there we go. So diversity's been redefined.
So it wasn't in the definitions, though you would expect it must have been, because it's not a new concept at all.
Don't we do maximum demand and diversity for decades?
I would have thought maybe it was around in the 16th edition it came out for a bit. I don't know.
Yeah,
went on a break.
But Dave, this is what happens. I get old regs blindness thanks to John, because I've read now virtually every single edition going back to the first, and we've done webinars on it. I become completely blinkered as to what was in what. Honestly, I can sit and talk about reg, and they'll go, "Oh no, that was in the 4th edition in 1910." Oh yeah, it's gone now. It's it's weird. Anyway, back to the definitions. Firefighting shaft. Very interesting. This firefighting shaft is a protected enclosure containing a firefighting stair, firefighting lobbies, a fire main hydrant, if provided, a firefighter's lift together with any machinery space. There's a lot of arguments at the moment over the whole thing, and Dan, if he comes on later, will probably go off on a monologue about it, because there's a difference between a fire evacuation lift and a firefighter's lift, and the requirements are totally different. So a firefighter's lift, fully fire protected, sealed, compartmentalized and all that jazz. But if it's a fire evac lift, it's just enhanced comms. And by the way, there's not really any standards that cover this in any great detail other than a firefighter's lift. Sorry, it's my little monologue there.
We kind of had that same debate when we had premature collapse, though, because a lot of people were saying, "Oh, it's just so that we can get out." But I was trying to say, no, it's so firefighters can go in.
Yes.
And there's really different distinctions in the way buildings behave.
Yeah, it's not this isn't for you. This is for the emergency services.
Exactly.
Basically, because too many have died. Functional earth conductor. a conductor provided for functional earthing. Again, I could have swore that was in there, but evidently maybe they're playing mind games. Maybe it's me. Functional equipotential bonding. Equipotential bonding for reasons other than electrical safety. Okay. I'm going to plead completely dumb on this. IT systems, maybe.
It's got to be that, or in sort of reducing interference or EMI or something like that.
Yeah.
It's just trying to create a clean system.
Crazy pills. Okay, cool. Generating set, which we know was in there, equipment converting non-electrical energy into electricity. There's 2 new notes. When a battery is supplying energy to installation, it is considered to be a generating set. Now, this is what boils my wee. Many years ago, 16th edition, chapter 55. I am 99.9% this stuff was in there, because I remember ringing up the NIC going, I've got a UPS. It's a generating set as per 7671. And I'm like, yes, it is. So why are we having to go over this ground? Has it come out and gone back in? I don't know. DC generating sets may use static converters when connecting to AC systems. Okay, well, you better design it right. And then there's also a new one, high-risk building. A building of at least 18 meters in height or having at least 7 stories and encompassing at least 2 residential units.
Yeah, there's a problem with this, because we'll see this later on, where this definition has been sort of altered and changed from its existing one. Currently, it's 8 stories, and now it's 7. But when we see it later, we'll see it doesn't actually say how many stories it has got at all. So, a bit of inconsistency with that one.
And that's the point of this. So I love the DPC webinars more than anything else, because it's this magical mystery tool. When we did the 18th edition, it was a huge controversial research piece that we did, and it generated loads of good chat. And then when the final 18th edition came out, it was like, oh yeah, okay, they've actually listened, and there's not just to us, but to industry, and there's lots of changes. So don't think for a moment what we're saying is going to be the final cut. This is about you doing your own bit of research. We're just prompting you to have a look at some stuff and giving an opinion. So here's a new definition that is strange. Inherently short circuit and earth fault proof. The state of electrical equipment or assembly protected against short circuits and earth faults due to suitable design and erection provisions. I quite like that. It sounds like an English gentleman with pipes and slippers wrote that. And just went, inherently short circuit and earth fault proof, my dear boy. What do you think? I like it.
I'm just trying to picture it.
It's basically stating that the equipment or whatever you do will be resistant to earth faults and short circuits. That's how I'm reading that. Equipment or assembly protected against short. So you're not going to build an assembly where you've got a 20,000 amp fault current and it's only rated to 10, because it wouldn't be inherently. So for instance, when you do a PFC reading, let's say you're Mrs. Jones's house, the PFC is 6.2 kA. Oh no, let's go 10 kA, and she's only got 6 kA breakers. You could argue that's not inherently, short circuit and earth fault proof. Where that fits in the regulations, though, I don't know. But I like the statement and the definition. So I actually hope that stays. I hope that stays.
Because I mean, that's assuming that we're talking about all of the equipment. So it's because things like short circuit proof, we don't. Well, we don't test that in our EICs in systems.
Well, Dave, let's go into the note, because this is quite a long one. So there is a note that says suitable design and erection. It's nice to see a note about that. Suitable design erection provisions include, and then it's got a number of alphabet letters that says, first one is A, arrangement of single conductors with basic insulation together with measures to prevent mutual contact and contact with exposed conductive parts. This may be achieved by installation in insulated cable trunking systems or installation in insulated conduit.
Right, so putting basic cables in an insulated system to make sure it doesn't make contact with any outside earth environments.
Yeah, this is basically class 2 equipment, but it's class 2 for installations.
Yeah,
it is. So we're going to be doing like plastic conduit everywhere and
Well, it's identifying that if you have a steel conduit on a metal trunking system with singles in, there's a risk inherently of having earth faults going to extraneous or other parallel pathways. But if it's an insulated system, it should have earth fault protection at least.
I hate to see. I'd like to see a bit more guidance on that bit actually. Part B: arrangements of single core cables or single core non-metallic sheath cables or rubber insulated flexible cables. That's all it says. C: provision of protection against mechanical damage and of safe distance from flammable material for non-metallic sheathed cables. Yes, common sense. Arrangement of non-metallic sheathed cables with nominal voltage of a UO of at least 0.6 to 1 kV, conductor to earth voltage, and voltage equals conductor to conductor voltage.
Yeah, this is just this just screams in the current version of 7671 when we talk about segregation of systems band 1, band 2, then we look at self and pelv and isolating self from pelv and self from self and self from earth. We just basically say put it in an insulated system, either being an insulated sheathing or insulated containment, insulate the system, and that looks like what this is, but obviously at installation mains level.
Well, the definition part E: use of cables with an insulation which is self-extinguishing and flame retardant gets my vote. Keep that bit, please. We shouldn't be using PVC cables anymore. 2024, we've got to stop.
Yeah, I think we can move on.
Part F: use of cables that are afforded physical protection by being buried, e.g. installation of cables in soil and concrete. And there is a bit coming up in the appendices, some new bits on current carrying capacities regarding cables being buried. So we'll get onto that. A new one. I don't know if this is like an acronym we can mock, but main functional earth terminaling earth terminal / buzzbar, or MFT, MFET. A terminal or buzzbar, which is part of the functional earthing arrangement of electrical installation, enabling the electric connection of a number of conductors for functional earthing purposes. So we went, John, I'm going bonkers here. In the late 90s, early 2000s, functional was all over the place. And I remember doing a job at Roding Valley Station. And there was a CER room, and the specification had functional conductor, and it was pink. And they ran a green and yellow and then heat shrunk it pink. This was in like 2001. And I was like, can somebody, again, please explain to me this functional thing? Because if I disconnect it, it'll all still work. So why are we calling it functional? And then everything functional seemed to disappear. So I think as a CBD piece, there needs to maybe be a functional earthing, what it is and what it now. In fact, you know what? If Darren Cranis is watching this, the ECA, he loves pink and functional earthing. So Darren, if you're listening, give us an ECA functional earthing webinar, please. Next one, monoblock battery with multiple separate but electrically connected cell compartments, each of which is designed to house an assembly of electrodes, connections, and possible separators. Note 1, the cells in the monoblock battery can be connected in series and parallel. 2, monoblock batteries for some battery chemistries may contain some protective measures, for example, cell monitoring and so basically that's like what I've got at my UPSs at work. So I have UPSs, they've got string temperature sensors, voltage sensors on the batteries, heat sensors, you name it, they've got it, and it's great. But I'm sure there's more applications of that in home storage and EV and all that jazz. One of the definitions that made me and John just go, ooh, henceforth the cat in shock, non-compliance, which was a definition, has now been deleted because it used to say a non-conformity that may give rise to danger. John, what does it now say?
Yeah, well, now it's a non-conformity with the requirements of this standard. So, in other words, non-conformities now, or will be, aren't necessarily something that's going to be dangerous.
Something that may not be dangerous, that could change some coding. More importantly, this standard is guidance. It's a means of complying with the intent of an electricity at work regulation. So you can clearly depart from it still, but what do you think of that, Dave? I'm not too bothered with it. I actually think that aligns better with the fact that it's a guidance note. It's a non-conformance to a standard which is inherently guidance.
It kind of goes back. I mean, we used to have this with old coding where we'd do the old C4 code doesn't comply with 7671. Yeah. Which we got rid of because it made the reports overwhelming and customers would just shelve them, and they still do, to be fair. But I agree, though, that we need it so that we can be more brave in using the term. Because if we just say that it's potentially giving rise to danger, a lot of people wouldn't use it because of the what danger and having to explain it. But if we can just say that there's no conformance for other factors, then yeah, more power to it for me.
Yeah, I like it. We're going to skim over these ones. There's a new term, place of relative safety, which is a place that is protected from fire, intended to only be used for a limited period of time, and a place of ultimate safety, a place away from the premises in which people are at no immediate danger from the effects of a fire. These terms are used on rail quite a lot. Place of relative safety may be a lift lobby with some fire doors, so that people in wheelchairs or PRMs, mobility impaired persons, can go wait for the lift to come and collect them, and there's a physical barrier between them and any chaos or fire.
We've been looking at these terms recently with regards to the right suitable designs for commercial EV charging, as to where we site EV charging installs and stuff, and these areas and how buildings operate in electrical situations are very important.
The EV standard that me and Dan wrote, it was as far away from the building as you can, i.e. don't put them close to it, put them at the back of the car park. Place of ultimate safety, that's generally outside, away, where you're safe, basically, from the hazards. The next definition, port, access to a device or network where magnetic energy or signals may be supplied or received, or where the device or network variables may be observed or measured. So that's transmission of energy and signals. That's PoE, basically. That's just up-to-date term. Let's go. Oh, there we go. We've got a lot more, but we'll skip over them. Power conversion, energy, electrical device converting one kind of power from one source to another. AC-DC converters, DC to AC converters, DC to DC charge controllers, frequency converters. Power port, a port of electrical equipment intended for connection of a power circuit. Primary battery, assembly of primary cells for use as a source of electrical energy characterized by its voltage, size, and arrangement. Primary cells, a cell which is not designed to be electrically recharged. So there's lots of new terms. Protective extra low voltage. PELV is a thing. So why is it new? Or have they just rewritten it?
It's new because it was not in the definition section before.
Oh, behave. Really?
It's all been defined. It's just, wasn't in the same with SELV as the next one. So
for those who know this book and who read it regularly and do this, it's the biggest head screw ever when you're trying to do this, because you look at it and you doubt yourself because you know it when you're like, oh, is it new? Oh, yeah. And me and John were looking last night at some definitions. We were going back through every single edition of regs going, oh, it's never been in there. Huh. But we've known about it for decades. That's weird.
So it is in there, but it's been retracted. That's what we're saying. PELV.
When you say it's been retracted,
I'm looking in the current book. It's in the current book, but in the draft, it's scratched red.
Oh, right. Okay. So this is our mistake. There you go. This is us being live. Thank you.
PELV is gone.
PELV is gone. Okay. And SELV is gone as well?
Let me go down.
Double check. Sorry. It's a live recording. We make mistakes. We are human.
SELV is gone as well.
Wow.
Now, I think to add to that, though, the power conversion we just introduced, we saw that in the previous version, a lot of products are now using power conversion technologies for fault situations, and there are issues with SELV and PELV being considered as a safety measure if it's power conversion. So it might be that there's a little bit of a play of it all here.
So new one, PNB, which we'll get onto, an earthing arrangement found in TNCS. It's kind of a cousin to PME. Where there is only one point in a network at which consumers' installations are connected to a single source of voltage. In such case, a supply neutral connection to earth may be made at the consumer's installation or another point. Me and John looked for this the other night and we couldn't find it, even though I swore it has been in past editions, but we think it was in DNO documents. Perfect example. Go on.
Correction. I have a correction. They haven't been removed. They have been moved. That's why they're green. So PELV has become protective extra low voltage. PELV.
Yeah.
SELV has become separated extra low voltage cells. So they've just moved it, which is why we're highlighting it and going, it hasn't always been there. It's just changing the definition. It's just letters.
There we go. Back on PNB, Blackwall station on the DLR has its own DNO transformer. And right next to the transformer on the other side of the wall, I know because basically I worked on it, there is a massive solid copper link between the neutral and earth, and that station is a PNB. I know, I witnessed it being done.
Just to add, you mentioned Mr. Kranitz. I think he recently did a good little article on PNB and PME.
Did he?
So
Okay.
if
Sorry.
if we wanted to do it, fine. But if you want to look at something, I think that the ECA did a video on it or an article on it. Because when I think about PNB right now, I think it's like he's just recently. I read recently that he's done.
I just think that the incredible pink jacket.
Yeah.
But yeah, okay. Residual current detecting device, RDCDD. We've covered this before in past podcasts. It's now defined a detection device having at least the functionality of detection evaluation of 6 milliamp DC, kind of the equivalent of the A-type RCD. Residual current protective device, RDCPD. Now, this is a new one on me. So, protective device with integrated AC, pulsating DC, and 6 milliamp detection, evaluation, and mechanical switching. I'll be honest with you, I've researched the arse out of this, and RDCPD.
The difference is that one of them is going to detect it, but not necessarily cut off the supply or whatever. It might just sort of signal an alarm or something for someone else to do something about it. And then the PD version is the actual device that if it detects this, it's going to disconnect your circuit, or in most cases for this, it's going to be the electric vehicle charging, which is where it's really aimed at.
Okay. Well, there's definitions for secondary battery, assembly of secondary cells for use as a source of energy. Secondary cell is defined, and stationary secondary battery. So lots of stuff coming out of all this energy efficiency. We're becoming far more integrated now in guidance and terminology for the many hundreds of thousands of batteries stored in people's houses.
Yeah.
Supplier is defined. A party having a contract to supply electrical power and energy. Don't really know why that's in there, but transfer switching equipment is in there. Equipment containing one or more switching devices for disconnecting loads. You could argue that's part of your prosumer world, transfer switching devices, doing all the neutral earth links and stuff. And then Amendment 3 again, unidirectional protective device, a protective device where it is intended that a power supply is only connected to one defined set of connection terminals and power flow is only one direction. And then there's a little note. The terminals of a unidirectional protective device will be marked indicating the direction of power flows, e.g. in and out or line and load.
Yeah, with an extra JW note, unless it's an old device.
Yes.
Yeah.
Now,
check with the manufacturer.
Part 3. Or listen to our podcast from last week, which never changes and never has any updates. However, before we get into that, this is where we do our usual thing and completely divorce ourselves from the book, because this is about context. So me and JW the other night, we went down the rabbit hole, Dave. Down the rabbit hole we went. So here is a summary and this is worthwhile getting onto the YouTube version. So ENA G12, which is the requirements for the application of PME to LV networks. Where connections are being made to DNO networks, the requirements of this document take precedence over 7671. So G12 is a higher standard than BS 7671, although most electricians may not know it exists and may not have a copy. Well done, industry. You're doing a smashing job. My sarcasm. One of the interesting things, and again, looking where we're going, this is the backbone reasoning behind the change. So 3.9 of G12 identifies something called a hybrid network, which is a new term. Although I think we've been saying it in our podcasts for a number of years. I think I called it a Frankenstein network, but it's defined as a hybrid network, a network originally designed as a TNS, made up of separate neutral and earth SNE cable, where combined neutral and earth cable, normally associated with TNCS system, has been inserted over time. For example, due to fault repairs, diversions, or new connections. I would argue that's a great way of defining lazy network alterations.
It's a very clever way of saying that, isn't it? But yeah, Frankenstein's a better term, in my opinion.
So there you go, ladies and gentlemen. Hybrid network is the official term. The E5 term is a Frankenstein network. So 3.13, and it's well worth getting a copy of it. I'll probably put the link in the YouTube video as well. PME enabled network, and PME enabled network is defined as a hybrid network where neutral earth bonds are installed in accordance with ESQCR. Yeah, right. PME-enabled networks such as a PME Earth terminal to be offered at the service connection. See figure 4.5, for example. PME-enabled networks enable the retention of Earths from S&E cables at service connections, provided they meet the criteria. So that kind of explains these Frankenstein cutouts where they leave the TNS connections. It's a PME-enabled network. And that's what that clause tells you. So let's go on to 5.1 because that rabbit hole got deeper. And we're going to read it out for everyone because it's really fascinating stuff. So 5.1, consumers on existing networks. Where a consumer's installation uses a separate neutral and earth terminal, all reasonable precautions shall be taken to ensure that the safety of these consumers is not affected by modifications or additions to existing networks. All right, then. How the bleep do you explain diverted neutrals?
Yeah.
It's great that you're trying to comply with ESQCR, but you're not in reality. Sorry, you're just not. Where CNE, combined neutral and earth, is introduced to SNE, aka, in our opinion, the lazy man's answer, existing separate neutral and earth consumer installations, aka when you look at a TNS head, may retain an SNE earth provided that, so you can adapt it PME outside and leave it TNS inside, as long as a continuous metallic earth return path exists to the source substation. Okay, well, you're repairing it with a PME, so you're kind of making it worse. But anyway, and then the next bullet point is they are connected to a length of electrically continuous, non-insulated metallic sheath cable sufficient to control the riser potential to acceptable levels under open circuit neutral conditions. Having considered the requirements of IEC 60479-1, by experience, this criteria will be met, provided the resistance of the earth of the sheath is 10 ohms or less, or an individual earth electrode is provided with a resistance of less than 10 ohms. Where in specific circumstances the 10 ohms value cannot be achieved, a value up to 20 ohms is acceptable, which comes from 7430. BS Simple 30 is acceptable where it can be shown the calculation that any voltage rise on the neutral of a three-phase cable is limited to 100 volts. What's your thoughts on that? Because I know what my thoughts are. I've got a lot of questions on that one.
Yeah, the problem is that, as it says there, that 10 ohms is from experience. So in other words, what they've done before. And then the thing about the calculation is impossible, because how are you going to calculate it on an existing network that's got bits of it installed all over the place, hundreds of meters of goodness knows what installed under the roads and been there for 100 years and all the rest. I mean, if you're designing a new one, then great, you can do all the calculations. But for any existing stuff, calculations are out the door because you just don't have the data for the stuff that's installed. So it's essentially saying, because we've done all this before for years, we know that in most cases 10 ohms or less is probably going to be safe.
So this is my problem. This document says it sits above 7671, but it's based on their experience.
Yeah,
Really?
This is just modification work. It's just jointing, and these guys put in the cable, they put the rod in the ground, and then they scarper.
So I did a piece of work with Eddie, where we had problems.
Yeah.
The DNO come out, they stick their earth rods in, 4 of them, hope to get less than 10 ohms, and away they go. All they're trying to do is minimize that step voltage around that building. So they're relying on their TNS, those lead conductors, to give them 10 ohms. If they can't fix it, they just try and reduce the resistance via other earth connections. And that's exactly what they did with Eddie. They dug up a cable, couldn't find a fault. So what they did was they just put loads of electrodes in to reduce that step potential. And this is at a bloody church. Now, if that doesn't tell you, you could ask them, oh, well, how can you assure me via calculation you won't get above 100 volts? They can't tell you. So I think it's fair to say, and I know John's probably going to mention this as we go on. Let me finish though. If these conditions cannot be met, there should be discussions with existing S&E consumers who may wish to convert to PME, providing their bonding complies with 521. So who would have a conversation with a homeowner and say, excuse me, love, you've got a 6 mil bond, you need to put 10 mil, get an NIC electrician in and pay a load of money to get your bond upgraded because our network is shot? How negligent is that?
Yeah. And no one's going to bother because
No.
the average homeowner wouldn't even understand what it was or why they need to do it, or the fact it's been there for 30 years just fine. And suddenly, oh no, you've now got to replace it all because of some excuse that's going on in the street.
So, dear industry, who is liable for this? Imagine there's an incident and someone gets a severe shock. Where does the liability sit?
Do they, when they make these hybrid networks and they put in these PME systems from hybrid networks, do they have to put information in to the installation to tell the electrician that that single protective conductor is actually part of a hybrid network?
Mate, when we were there, when I went to Eddie's issue at his church, when we were there, they didn't have a clue what we were talking about. I had to get one of our YouTube webinars up on my phone and show them.
Oh.
And they were looking at it going, oh, yeah, I recognise that. And I had to go through their standards with them. The field guys don't read these standards. They read their UKPN work instructions or their RAMs. They don't read this stuff. So it then carries on and says alternative fault protection may be provided if the consumer operates an installation forming part of a TT by installing a separate earth electrode. So again, customer pays for it, and fitting an appropriate protection in accordance with BS 7671, i.e. an RCD. Alternatively, S&E earths may be maintained by running a separate earth cable along with a section of CNE cable. Where this option is chosen, the neutral and earth should remain separate so as to be constructed as to minimise the risk of deterioration or damage. And we'll have a look at a photo in a minute because you'll see that. Some people see these earth wires going along and sometimes they go to electrode, but it's about maintaining a separate earth. The earthing terminal, section 521. PME earth terminals that can be offered to consumers unless there are reasonable grounds to believe either their installation does not comply with 7671 or the type of installation is not suitable for PME. See clause 6 as examples where it may not be suitable to provide a PME. It then goes on to say where a metallic gas service is provided to a consumer's premises with a PME earth, an insulated insert should be fitted into the gas service. How many houses have that?
Well, some do, but that's because it was put in like that when the gas service was installed or upgraded. But clearly, if you've got some ancient old thing in a cast iron or steel or whatever, who's going around putting these plastic inserts in?
I believe the
nobody.
customer.
Well, maybe.
So what I don't understand is I'm going to use an example. When the railway introduces a standard, the first thing people look at is it cost positive or cost negative. If it adds cost, it's hell to get through. Whereas on the networks, it's about removing cost from the network and transferring it to the taxpayer, which is fundamentally morally wrong. Here's the perfect example. And this is that was the reason behind this. And this is now part 3's biggest controversy. And it's a note. And it's on regulation 31221 on TN systems. And it says, note, if the distributor changes the characteristics of the power supply, this can affect the safety of the installation. Yep, no shit, Sherlock. Where it appears that a TNS earthing arrangement has been provided and the type of earthing arrangement cannot be ascertained by other means, an inquiry should be made. So what this is saying, it's not a regulation, it's a note, but it's inferring you now need to inquire. Now, this is a very slow set of steps to what the inevitable will be. We know what the inevitable will be because about 5 years ago, on the screen, I sent an email and it was in my area, earthing inquiries at UKPN. And it said, I'm undertaking research around electrical systems and we're doing the DNC. May I ask a question? Given I've read your recent suite of earthing documents, can you confirm the bulk supplies to homes are actually PME, PNB, configured in the style of TNCS? And one of their senior network engineers wrote back and said, yes, it's a reasonable assumption. And remember, in law, reasonably practicable is part of your defense. Reasonable assumption is PME has been around since 1970s. They are hybrid networks. We were talking about this 5 years ago.
Yeah.
At least 5 years ago. And we're only now catching up. And I'll be honest with you, this is the note that is quite embarrassing. I'm pleased it's there, but I think it could be better. But we are too slow as an industry to adapt. And I think the only thing that's going to end up happening is there's just going to be more carnage when it comes to DNO intakes, more issues to divert neutral. I know the IET are doing a wonderful piece of research, asking people to report it. They're not.
Well, years and years ago, when this was first put up, you're basically saying about it being crap being thrown over the electrician's fence, and it's just gradually coming in. We saw introduced in the change in the previous book where they said about TN systems, the recommendation of having an electrode, just a recommendation, even for TNC systems at the intake, to equalize that voltage in the ground. It's all these little measures. Obviously, that's trying to help prosumerism and island mode as well, but it's all connected.
But it's triage.
Yeah.
And this is why I put the nuclear image on the screen. Everything we're doing is triage for the network, who are a private for-profit company.
Indeed.
And it's the consumer that pays, and it's the electrician that pays, because we get a substandard supply, which we then get accused of something's going wrong or someone gets hurt. We don't have enough information out there for the smart technology, for the prosumer stuff. It's very high risk.
Even when we looked into the POP devices, and we determined that the reasons why they didn't come forward was because they really were a device that the distributors should be paying for, not the consumers. But we're still seeing very essential technologies with companies like Matty and stuff developing open pen protection technologies, but the consumer's got to pay for it. Yep. You know, in their design because of negligence on the distributor side.
Yep. One other alterations is in part 3, where you've got the diagrams of all the different systems. The TNCS PMB 3-phase system is in there. It's on the screen, where the neutral and earth are linked within the installation. A perfect example of that is actually Blackwall Station on the DLR, where you've got a transformer on one wall, and then next door to it you've got a big LV panel, nice solid copper bars, neutral and earth solid link.
Yeah.
And that's what does that station.
The key difference with these on the diagram is that it's still TNCS. The difference between PNB and PME is with PNB there's only one connection between the neutral and earth, and that's in the piece of in the dotted box there, and that's also where the electrode is. Whereas with PME, you've got a link there, but there's also going to be other links in the actual network itself, and there's also going to be other electrodes in the network as well, which is where the multiple earthing bit comes from.
So inherently, does that mean that the PME, with the additional multiple pathways through to the earthing system to the neutral, is a more hazardous scenario than a single connection PNB?
Not really. I mean, the only problem with PNB is you have only got a single link, and if that link goes away, then you're screwed, basically.
So everything else is just connected fortuitously.
Yeah. So gotcha. It's a similar arrangement, but it's just a question of there's only one link, and it's in your installation, or there's lots of them out there in the rest of the network. So, and it's also why TNCS is not the same as PME. It can be, but it can also be PNB and TNCS as well. So there is
that was actually a question that I got asked when I was interviewed by the NIC, and it was TNCS, what's it also known as? And I went PME, and he went, is it?
Mm-hmm.
And I was like, oh, okay, yeah. Because if you look at the analytics of it, it's only referring to the TNC bit, which is where the PME is applied. And it was that mindset they wanted of an area engineer to break down analytically. It was a great question. So just on that, protective neutral bonding may be adopted if the number of consumers is 4 or less, and their distance from the connection to earth is 40 meters or less. I don't know where this has come from. This is all new.
It's interesting.
The LV neutral conductor is connected to an earth electrode at a point remote from the transformer. Between the transformer supply terminals of the consumers, this connection should be made as close as is practical to consumer supply terminals in order to minimize the risk of voltage rise in the event of a broken neutral. PMB can apply to both 3-phase and single-phase, and where the source earth is installed within the consumer's installation, PME conditions do not apply. So actual guidance, I don't know where any of this has come from. I would like to understand more.
The only place I've seen this is in some of the network's actual design documents, and there was one example given where it was a rural installation with a transformer on a pole in the front garden or something, and that was the link, the PNB link there, and then you add your conductors from that to a couple of like cottages or something separate to it. So it does exist, but it's certainly not a common thing, and it's not something that you're going to come across that often. Most of it is where you've got a single site and it has its own transformer, and that's where the link is, and it just provides energy to that particular site only. So hence the railway place and various other larger installations.
Right. Well, part 4, and we were hoping to have Dan Jackson jump on. I think he's busy bouncing babies.
Yeah, he's just say he's not at the moment immediately available.
So part 4, John, do you want to cover this one? Lots of changes.
Yeah, this one, 41.1.7. This is currently higher risk residential buildings, which is currently defined as buildings over 80 metres in height or 6 stories. And notice we saw that 7 stories thing earlier. And it also goes on to say it's anticipated that this will be defined in legislation, which is subject to change and so on. So that's all going away. And then instead, it's going to be higher risk buildings. So notably not residential, just buildings in general. And these are defined in the current Building Safety Act 2022 and the Supplementary Provisions Regulations 2023. So now it's just saying, look in these other documents. That's your definition, rather than actually putting it in here. So it can and probably will change over time, because those particular things can obviously will be updated. Now, the next bit here, which is 4222, protected escape routes. This fits in with the definitions we've seen earlier, where it's all about the firefighting shaft and the protected stairway, and now it's firefighting lobbies, which is now part of those, and things like shaft or staircases have gone, and it's now firefighting stair and firefighting lobby. So it's all a bit of a twist on the words. The general intent is the same, but they've kind of mangled it around. And if you can see the image we've got here, the green bits are what's been added, red has been taken away, and the white is what we had anyway, and it's going to stay there.
Yeah, it's I think it's fair to say when they introduced more of this firefighting terminology, and it was always a bone of contention, and there was a lot of people who would argue, is it right, is it wrong? Our boy Dan is now chair of the Railway Industry Fire Association. I can tell you now, if he was in here, he would probably summarise this with, it's a bit of a mess. To be honest with you, 42221 currently states only cables that meet the following requirements shall be of limited smoke production installed in protected escape routes. And now we've got new bits that say fire resisting cables meeting the requirements of regulation 56081, or then it deletes a whole load of stuff talking about resistance to flame propagation and BSEN standards. It then introduces bunch cables with resistance to flame propagation according to the recommended requirements of BSEN 603323, but then it deletes the 60% light transmittance from part B of that regulation. Then in C, it then talks about single wires or cables where cable management according to D to E below are used, tested to the recommended requirements of BSEN 60332212, and shall be limited to the 60% light transmission. So they've moved stuff around. They've deleted bits and moved it around. They've taken chaos and created mayhem. I do think this is going to be the most difficult part of the regulations to get correct, because the fire engineering fraternity is quite a unique thing. As the IET chaps have said, we're not fire engineers, but we need to be mindful and cognizant of the protective measures when selecting and erecting for firefighting facilities, services, etc. And that's really important. So yes, we're not fire engineers, but we must consider fire safety of the building, the fixed installation, the utilisation, the emergency services. So there are terms that we're going to have to understand and learn, which is a bit of a weird one. Now,
I mean, the conclusion really is that you need to involve others, such as the people in charge of the building risk management, and you will need to seek, like 5839 and other standards. 7671 is still very bare bone with regards to wiring systems and identifying different areas. But really, it should just say, look, go here and do it to this. It should just strengthen that.
We'll come on to this later, because most people will talk about approved document B building regulations. That's where most people start. If they can't get approved document B compliance, as Dan will say, they'll move into BS 9999. If it's domestic world, it's BS 9991. If it's railways, it's 9992. And if they can't do that, it's 7974, which is a quantitative risk analysis, and that's a whole series of standards which Dan can talk.
And just to add to that, our industry will most often just go, 5839, which isn't one you've mentioned. And just to expand on, there are others than the one that you may hear a lot in our industry about.
The really good one that Dan keeps going on about, sliding doors. How many of them are connected to fire alarm panels?
Of course, yeah.
There's lots of standards we don't know about, little clauses and recommendations. This is the one that threw me. I think this is one that I just put the brakes on henceforth. I think the GIF on the screen of Homer saying insane. John, do you want to read this? Just because I may be reading this wrong.
Yeah, this is Chapter 43, Protection Against Overcurrent, and the scope of that. And there's a new note, which is actually note 5, which just shows you how many notes they've actually got in this now. And we've got flexible cables connecting equipment by plugs and socket outlet to fixed installations are not part of the scope of this standard, and for this reason are not necessarily protected against overcurrent. So you plug stuff in, and the bit of cable or the flex isn't, or doesn't have to be, protected against overcurrent. And if it is, it's not part of BS 7671.
So just for everyone, 4301 is the introduction of the chapter that provides requirements for the protection of live conduction effects of overcurrent. Now, this to me, Dave, I want you to ratify this or tell me to shut up. This to me says that potentially you could have a plug and socket that isn't fused, because you're then relying on the fixed wiring overcurrent protective provision. That's what that says to me.
Flexible cables connect equipment to plugs and sockets to fix are not part of the scope. I think what it means is anything that's on a cord set that's plugged into an accessory like a 1362. There's a fuse there, so I think that the overcurrent protective selection requirements of that cord set isn't necessarily within the reach of 7671, as the overcurrent protection is in the construction assembly of the product that the plug and the cord set is attached to.
I was thinking 7909, something had slipped from maybe there.
7909 will, in the sense, well, with 7909, we have 16 amp, 32 amp, 63 amp, but we just make sure the conductors are sized to that overcurrent protected device. We have the MCBs. So we still have overcurrent protection in there. Any time where we split it down, for example, a 32 amp split down to a 16 amp on a 32 amp feed, it's non-compliant. You have to have overcurrent throughout the system. This
is why I love this being a DPC, because when I read this, my initial thought is I can now remove fuses from plug tops. Is this the end of the 1363 plug top? What could this interpretation be? Then I thought it's 7909. You rightly said, well, if it's an assembly, la la la.
Well, I went to do an observation of an installation at Warner Brothers recently, and the whole thing was power track systems with desks. Remember when we did the equipment in furniture?
Yep.
All that equipment had to have overcurrent protection in that constructed assembly. So whilst the power track and the sockets on that system and the systems and the feeds in that system to the power track has overcurrent protection to 7671, all the cord sets on the plugs and all those things are inherently under that assembly's standards. And I should assume that that's probably what it's pushing to. That's the only thing I can kind of connect with that.
So there you go. So that was one that I thought was a show-stopping, controversial, insane, potentially controversial means of interpreting.
By plugs and socket outlet, it doesn't say to BS. So I mean, that doesn't mean luminaire support couplers or anything like that, does it? That just means a plug and socket arrangement.
Well, any
60309. Well, yeah. I mean, are we just talking about 1363, 60309, and the other kinds that you see in accessories? I think that's what we're talking about here.
It doesn't say it's open to interpretation, hence the DPC. So I think that needs to be reworded, or you can't explain a note with a note, can you really? But That's an interesting one anyway. Right, I'm going to move on. 43331. These numbers I still prefer when it was dash. Where automatic disconnection supply is inappropriate, the device protecting a conductor against overload may be installed along the run of that conductor if the part of the run between the point where a change occurs, i.e. cross-sectional area, so if you've gone from a 2.5, let's say realistically you go from a 35mm armour down to a 2.5, let's say. Some people have done that. Method of installation, type of cable or conductor, or environmental conditions, and the position of the protective device has neither branch circuits nor outlets for connection of current using equipment and fulfills at least one of the following conditions. It is protected against fault current in accordance with the requirements stated in 434. Its length does not exceed 3 meters, and it's selected and erected to be inherently short circuit proof and earth fault proof, and it is installed in such a manner as to reduce to a minimum the risk of fire and danger to persons. That's quite a good note, that. Locating the wire in the enclosure manufactured from non-combustible material is a measure that will reduce to a minimum the risk of fire. Yeah, totally agree. Bit of metal trunking or conduit. A device for protection against overload need not be provided for circuits for telecoms, control, signalling, and the like. John, what do you think of that one?
Yeah, I mean, 43331 does exist at the moment, and it's along the same lines as this, but it's been totally rewritten. And then you've got all these extra bits now about the length of 3 meters and the other definition we saw earlier about the inherently short circuit proof and so on. So it's been massively expanded, and also in some other ways sort of more restricted, because at the moment there's no restriction on length, for example, so there's no 3 meter length thing.
No.
And then the bit about so it's sort of moving it.
It's inherited that from the fault current, hasn't it? Because that's in fault current, the 3 meters.
Yeah.
It's a really I think the opening statement's weird, because the original one was a device for protection against overload need not be provided, and now it's gone on this monologue. But I do actually agree with it to an extent. So on the underground, for instance, on the 110 volt sockets on the platform, we would design for volt drop, say 30, 50 mil cables that you'd have to run along the platform because the volt drop on 110 was ridiculous. Take it into a junction box, fixed base connectors, and then drop down to like a 10 mil or a 6 mil to get it into the back of the 110 socket.
Yeah. Another common example of that is a car park light circuit, where you may have a long run to the outside car park. You'll have like a 6 mil, but you may have a 6 amp breaker in the board. Yeah. So when you change a 6 mil down to a 1.5 or a 2.5, you don't have to change the overcurrent device because you've got it at the beginning.
Yes, yeah. So I think that's what they were trying to say, unless they were trying to say also don't run a 1.5 mil and then transition to a 35 mil.
It's just about the way it's running. It's basically it's always been there. It's just anytime the circuit run goes to a point where its current carrying capability or the sizing for things like volt drop changes, overcurrent protection needs to be considered if it's ineffective at that point. If it's not ineffective, then there's no need to change it.
434211, except where regulation 43422 or 434.3 applies, a device for protection against fault current may be installed other than in specified in regulation 434. And I think this is very similar to the last one. Basically,
it's the same. It's the exact same thing, but this is fault current, not overcurrent.
Yes,
overload current.
So it talks about not exceeding 3 meters in length, inherently short circuit proof, minimum risk of fire, and in non-combustible enclosure. John, do you want to do 4343?
Yeah, so this is emission of devices for protection against fault current. Now, this has been reworded, shall we say. So the red there is what we currently have, and then the green we've got is what it's going to be. So it's going to end up as a device for protection against fault current need not be provided for a conductor connecting electrical equipment that is a source of energy to an associated switchgear or control gear assembly where the protective device forms part of the assembly. Essentially what they've done, they've replaced words like generator, transformer and batteries and things with equipment, switchgear and assembly. So again, the intent is the same.
They've expanded it. They've expanded it to reach more things.
Yeah, so it's more generalized and covers a lot more stuff. So
I don't really know many installations where you wouldn't have fault current protection other than on the distribution network. And that's kind of like a hope and a prayer. Fault protection.
Common example of things be like safety circuits, excited circuits, lifting magnets, things like that. But otherwise, yeah, not really.
Okay.
Yeah, it's a fairly specialist area.
Yeah, I was going to say that's don't get that on railway stations. John, would you like to start swearing about this section because it's all been deleted?
Yeah, part 4, chapter 44, protection against voltage disturbances. All of this has been removed and has gone away. So it's used to be where it's basically surge protected devices and where they were supposed to be put in, and whether how much distance you've got in the network, and whether it's overhead and underground and that sort of thing. That's all gone away, and it's not being replaced with anything. So it's just chopped out.
Okay, so hang on. So it's just gone.
Yeah. It's not surprising, to be honest, because you might remember in a previous version there was that diagram with voltage, the lightning map, and all of that.
The risk level, yeah.
Yeah, and this is the equivalent in terms of how long your conductors come into your building are, and whether they're overhead, underground, or half and half. So that's all going as well. So it's really just continuing on what they deleted previously and just cleaning the whole lot out and getting rid of it.
And it's not been, I mean, you guys have read this. I've not had a good chance to look at this, but it's not been like put in other places here in overvoltage. It just disappeared.
Yeah, it's just gone.
Oh, wow. Okay.
So
what's that? Till next time when it comes back.
Well, yeah, because it's silly. All of this is still exists in the other. Yeah, it exists in the other standards that this was taken from. It's just gone away from here, but it's obviously still in the other standards that it was copied from in the first place. So
yeah, it's a bit of a. I'll be honest with you, it's a bit all over the place. So there is a chapter 44 here in the DPC, and it does have some very silly bits and bobs, but there are stuff that are deleted. So like risk management, protection against transient over voltages, protection against transient over voltages to strike or stroke. There are some weird it does seem somebody's gone into section 44 and done an absolute hatchet job on it.
But we're still saying 62305 is outside of scope, I assume.
Yeah, the whole there is it,
even though it says here
they
in
have
note
basically
1,
everything that's on the screen has been completely deleted from the regulations. And it actually has Annex A443 and Annex B443 deleted by Amendment 2 and Amendment 3.
Okay.
Ironically, it actually says deleted by Amendment 3 2026. So that's another mistake.
Yeah.
Oh, yeah.
Because obviously we're not in 2026 yet, so
maybe we have a time machine. But so just for my simple brain, it kind of still talks about measures against electromagnetic disturbances. But how does this affect the SPD world is the question that everybody's kind of... Because for me, it's still saying you must take some sort of steps to... But it's not... I mean, okay, let's take a step back. 18th edition, we had all this chaos of, the SPD companies are making a fortune. We've now got to do this FELV over 1, distance from the transformer, blah, blah, blah. Massively over the top calc. The argument of you don't have to do it, the proportionate cost against the value of the installation. And we have taken steps back. It got reworded, didn't it, in Amendment 2? So it was more simpler and it was easier and more logical. And they took all the formulas away in Amendment 2. But now it's been hacked again. It's almost, and John, tell me if I'm wrong, this is almost 17th edition-esque levels of, well, it's there, but we're not going to tell you too much.
Yeah, I think it's just going to come down to the fact that surge protection devices are still a thing and you still need them. But in terms of what you need, it's just going to come down to either other standards or, in most cases, the manufacturers of these devices to advise on what you should have, rather than people doing all this calculation and getting this information and trying to work it out themselves.
So I've just found, before we go on, Regulation 44311, there's a note, and this is it. This is a new note, and it says, for risk management for protection against transient overvoltages due to direct or nearby lightning strokes on the structure, see BSEN 62305-2.
Yeah.
Okay.
So everything that's gone into the regs regarding surge protection has basically been thrown in the bin.
I don't know. There's going to be work here. There's got to be work done on this.
It has. And so I'm going to ask the question on behalf of what most people are asking. Who's giving me my money back? Who's giving me my money back? Because I'm not being funny. This has cost a lot of people. By the way, just to be clear here, the surge protection industry, we are now of the mindset of it's an essential protective device. For what it does, it's a given. For the domestic home, type 2, every day of the week, we are 100% sold on it. But my God, the journey that that's gone on has been the most conflicted, convoluted load of rubbish ever. I'd love to know what Dane and Surge Devices think about this. I really would, because I'm sure they'd probably be banging the table in the committees. Anyway, let's move on. Part 5. So, table 51, identification of conductors. Lots of new little terms. CPFE, combined protective and functional earthing conductor, which is green and yellow. So GNYE. Why are we introducing all these acronyms? I don't know. There's a new term, CPFB, combined protective and functional bonding conductor. So CPFE and CPFB, which is also green and yellow. We then have functional bonding conductor, which we know to be pink, but again, that's been reworded. And then neither the designation FE nor the bicolor combination green and yellow should be used to identify functional. So anything that's functional should be effectively pink, or as I like to call it, the Cranis conductor.
The Cranis conductor. But it's interesting though, because like a pen conductor should be green and yellow with a bit of blue, or blue with a bit of green and yellow. Why can't the CPFB be green and yellow with a bit of pink?
Totally agree. Take one of the stripes out, change it with pink, job done.
You know? Or just put a tiny bit of pink over the end of it. I don't know.
There's a recommendation. Doncaster cables. Why aren't you making it? You're making earth, sure. Make this. Make the Cranis conductor. Give Darren what he wants. By the way, for anyone listening, Darren Cranis is a technical manager at the ECA. You can't miss him. He's incredibly bright clothing. Yeah. We've known Darren for years now. But yeah, so there you go. So if you want to put a comment in, rename the functional bonding conductor to the Cranis conductor, the CC. I'm sure he would be over the moon.
I mean, you can obviously label it, you can label it CPFB and CPFE, but you're supposed to have color or alphanumeric. And if you're going to do color, we need some pink on something that's got functional earthing in it.
Yeah. Right.
Or bonding, functional bonding as well.
Now the one that makes you blink, John, please.
Yeah, right. This is chapter 52, and it's 52151. Ferromagnetic enclosures, electromagnetic effects, and this is for AC conductors. What it currently says, and I'm sure everyone's familiar with this, it says where such conductors enter a ferrous enclosure, they shall be arranged such that the conductors are only collectively surrounded by ferromagnetic material. So in other words, you put all the conductors through the same hole in the metal case. However, that part has been deleted. So what now it's going to say, it's where the conductors enter ferrous enclosure A of switchgear and control gear assemblies conforming to BS ENIC 61439 series. Circuits with the design current of the circuit exceeding 200 amps shall be arranged so that the conductors are only collectively surrounded by ferromagnetic material, which is basically the same as we've got, unless the assembly manufacturer's instructions have confirmed the rated current of the circuit by temperature rise tests of the assembly. So in other words, if the manufacturer says you don't have to do that, you can stick the conductors through separate individual holes and then just to hell with the rest of the overheating. Or B, if it's not part of that particular standard series, then they shall be arranged so that the conductors are only collectively surrounded by ferromagnetic material. So in other words, you still have to put them through one hole, or unless the manufacturer says that it's perfectly okay, you can just stick them through multiple holes and some overheating may occur, and that's perfectly fine because they've already tested it.
So are we suggesting here that, I mean, I remember you did a video on this, John, to kind of illustrate this theory, and you said there's heating. It was negligible heating.
Yeah.
And I've seen it myself with a quite high resolution thermal imaging camera. There is heating that happens. what they're saying here is that the heating is not really such a concern unless we're of current of the magnitude of 200 amps. Is that what we're getting to here?
And apparently, if the manufacturers stated that that's fine.
Yeah.
The only problem I see with this is that if they've tested it at 50 hertz AC, that's great. But in the real world, what if it's not all 50 hertz? What if there's a load of harmonics in there at much higher frequencies? Then the heating effect is going to be considerably different. Generally, if you increase the frequency, the heating is increased. So
an IB of 200 amps may not represent the heating that you see. If you've got harmonic current there, it's going to be a much larger. Yeah. I think I think that this could probably catch some people out at some point.
You know what I'm going to say?
What are you going to say, mate?
Yeehaw!
Yeah.
Yeehaw!
This is one of those regulations.
Cowboy.
This is one of those regulations. Like, what is the reason where this was needed? What installation circumstance are we having where this has to be considered?
Encourages the lash ups to continue and be justified. We have spent decades and decades and decades going through this, making sure you're slotting, making you use your ferromagnetic material and all the rest of it. To ask permission from the manufacturers is like turning around to a clerk of works and saying, "Can you let me get away with that lash up?" No.
Yeah. And the thing is, a lot of manufacturers will have an answer that's yes to one question, but there's so many variables that they may not think of. You know, they're very linear about. I've had the same issue with boards being mounted outside and the impact on devices in there, and the manufacturer's very much pointing at a certain test, a certain arrangement, and they won't look at all of the variables that are actually possible with the system you design. So yeah, I don't like this viewpoint at all.
No, and there's a picture on the screen that just shows the current flow in and out, and where you get Eddie and the band striking up. Although John has a wonderful video where he goes through all this and does all this. John, do you think this is a successfully worded reg or one that needs to be pulled apart by everybody?
It isn't particularly successfully worded, and as we'll see on the next page, there's no note as well, which attempts to explain it even further, which kind of indicates it's already failed. The note is that for low voltage switch gear and control gear assemblies to DSE and IC 61439, conductors in AC circuits with a current rating not exceeding 200 amps can pass through separate holes, etc., in ferromagnetic enclosures. Currents above 200 amps, where they go through separate holes in a ferromagnetic material, need to have been verified by temperature rise test. So again, if it's under 200 amps in theory, you can now shove them through separate holes. And if it's only 50 hertz, it's probably going to be okay because the temperature rise is going to be fairly small. Unless, of course, there's a load of harmonics, which you're going to inevitably get on any modern installation because of all the electronic stuff that's connected, in which case the heating could be dramatically more. Unless the manufacturer has done their temperature rise test on it, in which case you can do what the manufacturer says. But the same problem applies there, that if the manufacturer's tested it at, say, 400 amps at 50 hertz, but then, of course, you stick it in a real installation and there's a load of harmonics in the many higher frequencies there, and it overheats and melts. So it's just asking for trouble.
I see there being a problem where, because we have these large clamps for tails, I see a situation where some smarties will go, okay, I'll do one entry for line, one entry for neutral, and then obviously they'll put it on a system that's maybe pulling a few amps, and then a year or two's time they'll jack the load up. This is just creating potential problems that we don't want.
Yeah,
I can see more and more electrical installations now suffering from more and more problems. And I went and had a look at a house where it had rather large G99 solar PV battery storage under a staircase, baking hot. The whole installation was just literally shocking. And when you apply some of this stuff into it, it's just going to fail even more miserably. But yeah. One of our favorites, 52110, installation of cables. Note 5. The intent of this regulation is to prevent general collapse of a wiring system. I can't believe we're still having these conversations. To the effects of fire, so that they would hinder the safe evacuation, rescue, or access to firefighters. It is not the intent of this regulation to provide support to maintain circuit integrity of life safety and firefighting under fire conditions. So these requirements are addressed in 56 and in Codes of Practice 5266 5839 and BS 8519, as well as 7671. So this is the long and old story of premature collapse. Dave, I think you were one of the first people to start the campaign with your wonderful father. I think it's fair to say that
the industry was all shouting about, oh, it doesn't matter because you can get out in 30 minutes. And I said it's all about integrity of the system for the firefighting activity. And it could take 45 minutes or so for a crew to arrive, for an assessment to be taken, for them to know there aren't people in, for them to then plan to go in and tackle a fire. It was obvious to me as to what the intent of the regulations was, and amazing how much other crap there's been discussed around it.
Yeah, I mean, 52110 is about non-sheath cables for fixed wiring should be enclosed in conduit ducting or trunking. This doesn't necessarily apply to a protective conductor. Non-sheath cables are permitted if the cable trunking provides at least a degree of protection of IPXXD or IP4X. Well, that seems to be an alteration. And if the cover can only be removed by means of a tool, and then it's got loads of other bits below it, and then it says wiring systems shall be supported such they will not be liable to premature collapse in the event of a fire. And this one regulation has caused a lot of arguments and debates over the years.
Yeah.
And I think your father even did one because he was a reserve firefighter. And I think my one was, given I've seen so much lash ups, if you're going to argue over this, you've got a bigger problem with yourself. Very simply, you have a serious moral compass issue if you are going to justify lashing cables across suspended ceilings and all the rest of it. The amount of arguments I've had with people over, well, 1 in every 10 plastic tie wraps, and you're like, oh, come on, guys, seriously. There are enough British standards that warn against this. Enough people have died. The question which got raised, and the IET covered this quite neatly in their webinar, was people would take the whole premature collapse, integrity of the cabling. Does that mean the cabling needs to continue operation? Which was what the question which drove this. So the IET very succinctly said, look, this additional note is about, we're not talking about circuit integrity. Circuit integrity will be covered under BS 8519, 5266 and 5839. So that's emergency lighting, fire alarms, and life safety systems or other systems that's deemed essential.
Yeah.
How you do that. I think some places are immature, some places are very good at it.
This is just about a nest of disconnected, powered down junk falling down, entangling firefighters. That's all this is.
Yes. John?
Yeah, I mean, it's chapter 52. This is 5269. Protection of multi-wire, fine wire, and very fine wire conductors, which exist already. And essentially what I've got now is a little table which gives you some of the conductor classes 1, 2, 5, and 6, which are basically solid, stranded, fine, and very fine wires. And there's a note which is conductor classes refer to the different conductor constructions as defined in BSEN 60228. That's existed forever. It's just they've put a little tiny bit of it into BS 7671.
Okay, before we go on to the other one, just a quick note, 5226202, cables installed in wall or partition, which was table 52.1, has pretty much been rewritten. The hole, is it 50 mil deep? Is it not? They've evidently gone and looked at the wall construction type, whether the wall has metallic parts or not metallic parts. Is it in a prescribed zone? Is it not in a prescribed zone? Does it need additional protection by RCD? So they've rewritten that bit. That's one that it's worthwhile noting. We don't have a slide on that, but
this is where they could take advice from these other countries that put more illustrations in this book. All you have to do is have an illustration of the wall with the zones and the methods illustrated. You know, some of the other countries have illustrations.
You mean like they do in Ireland?
Like they do in Ireland, in Dubai, all these places. They just, because it's one of those regulations. That regulation in particular about the zonal and all that. It's so wordy. And it's so complicated, especially in training, to try and get them to picture it. So picture it, you know. It just would be easier.
John, would you like to do the next one?
Yeah, this is 53132, unwanted tripping. It's note 3. There seems to be changing a lot of notes on these. And at the moment, note 3 is in the case of transient effects, tripping the RCD may occur by charging of bypass capacitors or by other electromagnetic disturbances. and that's being deleted, and it's going to be replaced with a new note 3, which is if multiple items of equipment with EMC filters, for example ICT equipment, are not switched on simultaneously, the protective conductor currents and or earth leakage currents should not exceed 50% of the rated residual operating current instead of 30%. So the only real change here is that at the moment, if you're going to put an RCD on the circuit, you're not supposed to have more than 30% of that RCD's rating as leakage. So for a 30 milliamp, it should be 9. But now, if in this particular circumstance, it can go up to 50%, which is sort of pushing up against the bottom of the actual trip range.
The threshold.
So it would be 50 milliamps in the case of a 30 milliamp
device.
But again,
John, this is a regulation not many actual people follow. It's not exactly people go around and design the fixed equipment and the leakage. They don't bother because it was, if you remember, it's one of them technical reports that we covered in a past podcast where there was a formula for number of equipment times 0.75 would give you the leakage. You can then go to the product standards and you could work out what your leakage was. This is now saying, well, rather than being 30% or 9 milliamps or whatever it was, you can now have 50%. So you're at 15 milliamps. So you're right, some devices may be that sensitive. It will be quite interesting. But for those who may not understand or remember this reg, this is the one that in Amendment 2 they introduced the use of RCBOs for final circuits rather than RCDs, and we called it the death of the split load board. So this is just one of the little conditions of that regulation. But be interesting to see whether this gets reworded or maybe explain a bit more.
I can kind of understand it though, because I mean, like in the 2396 project that we have right now, which was a library for last year, there are guys who are putting so many sockets and so many circuits because they'd have 1 or 2 laptops, and they go, well, a laptop would have this kind of leakage, and they go, we can only put 2 or 3 sockets per RCD.
Yep.
But because the intent being 9 milliamp, obviously what they're saying here is really we're talking about a sudden load or simultaneous load pushing to 9 only. But if things are over a period of time, we can go up to half I delta N, which I think is where 7909 goes to as well, is to 50%. But as you say, it's something that on paper we can kind of make some guesstimations. But for ordinary users using socket atlas circuits, it's basically it's a shot in the dark, really.
You've got no idea what they could plug in. It could be even if it's the same type of equipment, one laptop power supply might not be the same as another one.
Exactly, and we had to do a little bit of diversity with this. So we'd say, okay, well, most users would probably have tablets or Chromebooks, which would be about up to maybe 0.25 leakage at best or milliamps. Whilst my power laptop is like 3.5 to 5, but no one really goes to the library to do gaming. They just go there to do browsing activities. And we had these conversations in the calculations, because it does when you have to do a design, you have to get it through assessing. They worry about it because it is one that they're not really supported with. We found that Schneider document was pretty useful, didn't we? Which had a load of leakage currents that the product standards gave. But
it was useful because it was either that, which you can get for free, or you got to actually go and buy the suite of 100 and something individual standards, which cost about 20 grand or something ridiculous. So obviously,
I do get this. I do get this regulation. I think that they probably will reword it a little bit.
Well, moving on, 53133, one of my favourite regs, because it just explains what we've been banging the drum about for ages, types of RCD. And it starts the same, different types of RCD exist depending on their behaviour and the presence of DC and frequencies. If you go all the way down, right to the bottom of part D, there is 4 notes across this regulation. And it says in note 4, which is a new note, all RCDs connected in series should be appropriate for the type or types of residual current expected due to the characteristics of loads and or possible fault currents. See figure A53.1. Now, this to me is just a good old-fashioned, it's under the part for type B. This is the one that we've been saying in previous podcasts, separate your Bs from your As and ACs. Make sure you don't just have selectivity of current, but selectivity of time and selectivity of type. That's what that is. So it's time, type, current. We need to think about that now in selectivity, and it's really good to see that that's working its way in. Although I still
Yeah.
think they should introduce the B type. I know it's a
Well,
DIN.
just
B
just
plus.
to add to this, I mean, this is the only change we've got right now, but we are seeing this push in the B direction in everywhere, and 2026 is quite far away. So there may be a little bit more support for the B closer to the time.
Can I predict that Type B plus will be in the regulations by, I'm going to say 2032.
32, okay.
Yeah.
So 2032, I might be sitting there going, "I told ya." Anyway, right, moving on.
Yep.
Oh, blimey, this is a long one. Current ratings, completely rewritten. John, you can do this one. This is a good one for you.
Yeah, so 5364202 used to just be current ratings, and now it's this enormous pile of text about coordination between low voltage switchgear and control gear assembly and overload protected devices. So what we've got then is the characteristics of a device protecting a low voltage switchgear and control gear assembly against overload shall satisfy one of the following conditions. A, the rated current or current setting of the upstream protected device is less than or equal to the rated current of the assembly and any outgoing unit. Or B, load curtailment should be used to limit the maximum current demand for the assembly. Or C, the total connected load without diversity does not exceed the rated current of the assembly and any outgoing unit. And where load curtailment is used, and that's basically where things are going to be switched off if the current goes over a certain level. Good example is electric vehicle charging again. So where that's used to limit the maximum current demand for the assembly or outgoing unit, these following conditions shall be met. Ion A and ion C shall be greater than or equal to the limited maximum current demand using low curtailment. Diversity shall not be used as a means of low curtailment, low control or overload protection. And then we have 3 notes. Note 1, examples of a low voltage switchgear or control gear assembly are a distribution board and a consumer unit. An example of an outgoing unit is an RCCB. Note 2, ion A is the marked rated current of the assembly. Ion C is the outgoing unit, as in the RCCB, for example. Enclosed rated current inside the assembly, which can be lower than the rated current of the device according to its respective standard. Ion C should be stated in documentation supplied with the assembly. And then note 3, examples of suitable overload protected devices are all the things you already know: fuses to BS88, circuit breakers, RCBOs, and so on. So a lot of text there, but the real main points here are that you can't use, in this situation, you can't use diversity to sort of reduce the total load on these devices, but you can use load curtailment, which is basically some monitoring equipment which will turn down, say, the rate of EV charging or whatever else if the current goes over a certain amount.
So it's introducing load curtailment. It's a long way of putting it.
Yeah, basically, yeah.
Yeah, which we've known about because from the start of EV, load curtailment was a thing. You had your CT on the on your outgoing meter, and that would then regulate your charger. But now a lot of them are all smart, and they're doing it internally via their own internal CT. So load curtailment is officially in the regs. There we go. This is an interesting one. This was raised on the IET webinar. So 537.4 firefighter switches. And basically, a firefighter switch shall be provided in a location specified by the fire engineer. That term, the fire engineer, which electricians are not. But then again, a lot of companies don't have fire engineers. They have a responsible person. So there's a bit of a gap there. Weirdly enough, Dan is my fire engineer for my railway to support the building's overall fire strategy. Now, that's if the building has a fire strategy. 99.9% of all existing buildings will not have a fire strategy. They will have a fire risk assessment done annually, and you better hope it wasn't Joe Bloggs, who also maintains the fire photocopier. Now, examples of firefighting switch can include outdoor lighting. We know, some of the old stuff goes up to high voltages. Indoor discharge lighting, locations where the fire authority might require the facility to isolate a part or parts of an installation in the event of emergency, and installations in certain premises subject to licensing conditions. So this is part of this new reg. Now, firefighter switches used to be just for the outdoor lighting, high voltage stuff, and that was it. I've had a fire recently, and And one of the requests from the fire brigade was, we can't isolate the power. Ironically, what caught fire was the main switch, which was the isolator for the power. So afterwards, the suggestion came back of, can you put a firefighter switch, a very simple firefighter switch, that will isolate all sources of supply? Now, in that station, there's two 400 amp supplies and two 200 amp supplies for retail. Now, if I did that, I would need then contactors sufficiently rated for that load, a control system for that, and then effectively a control switch, which would be the firefighter switch, to drop all them supplies out. That's quite costly and space consuming. So this is going to be an interesting one to track as far as how it impacts, because I don't disagree, by the way, with a firefighter switch. For instance, on buildings where there's solar PV, the fire alarm panel, if you're not already, should be wired to tell the solar inverter to shut down. That way you don't have live energy still being generated from a solar system in a building that's supposed to be dead. So there's lots of considerations we need to take now to protect firefighters electrically as well that may not have been considered sufficiently. I would ask the question, are the fire brigade still doing robust training like they would have done with your old man, Dave? Probably not.
Not well. They'll probably say, yeah. But
again,
what I've heard,
just on a reasonably practicable perspective, the cost of doing what I was just talking about on a railway station, is it proportionate for a 1 in 10 million event that may never happen? I don't know. It's an interesting one.
Another thing that's moving in this space at the moment, obviously, is EV as well. And we know that as we start putting stored energy everywhere, battery systems in cars, battery systems in properties, the insurance companies are getting more and more involved and more concerned with how fire systems interact with the sources of energy feeding and suppression systems. And part of that whole process also is tackling fires as well, and if we can't find the right ways to isolate systems. So I won't be surprised if also soon there's some extra work there. I'm actually reviewing some bits at the moment for city and guilds and stuff on this.
Yeah, it's going to be interesting to see where that all goes. John, 545.
Yeah, 545 is functional earthing and functional equipotential bonding for information and communication technology, equipment and systems, also known as ICT. This is a whole section here, which is actually completely rewritten and is mostly new. There's 2 entire pages of that. We're not going to go and read the whole thing. But again, it fits in with what we've seen previously with this functional earthing and the pink conductors. So just be aware there is that entire section there.
It summarised that you're basically going to have a new main functional earthing terminal.
Yeah.
So this is about configuration for EMI, EMF, etc.
Well, it makes sense for a board to have a terminal for functional purposes that's identified pink that's fed from the other terminal, which is protected. And a completely separate way to connect this. And this is the whole direction things are going to go with telecommunications and data.
Yeah. 55171 basically completely rewritten, deleted and rewritten. When a generating set is used as an additional source supply in parallel with another source, all the following should be fulfilled: protection against thermal effects in accordance with Chapter 42, protection against overcurrent in Chapter 43. Almost like a fundamental principle, this bit, really, isn't it? Where an RCD is providing additional protection in accordance with 415 for a circuit connecting a generator to the installation, the RCD should disconnect all live conductors, including the neutral. So that's an interesting one. So where you've got an alternative means of power, you now need effectively double pole RCDs, not single pole. So will single pole RCDs now become a non-compliance?
They probably will. However, you can all see most manufacturers are now doing, like the RCBOs, they're not doing the solid neutral ones anymore. They're all moving to the switch neutral anyway. So I think we're going to end up there before this is even in force. We're going to be there anyway, in that there's just going to be having a switch neutral is but standard thing.
Where energy flow is bidirectional, suit a protective device. So they're warning you there. You must choose the right one if you're going to. So if you're a battery installer or a solar installer or a wind installer and you're doing all this stuff, you're not just going to connect it into an existing board anymore. You're going to make sure that board complies with the intent of these regulations. The last one is, and all our lettering is gone weird for some weird reason. It's part right. So a source's reply shall not be connected to the load side of any RCD, providing additional protection in accordance with 415 that is shared with other circuits. For example, connection to an RCCB load side and a split load consumer unit, or distribution board where the RCCB is feeding a number of circuit breakers. And they're right, because what this means, guys, tell me if I'm wrong here, that if you're connecting it into an MCB, let's say it's a connection from solar, it's going into that RCCB, but the fact of the matter is you're also feeding all them other circuits in parallel, which can be quite dangerous. So even though you may have your RCD disconnect, you're actually still parallel feeding a load of other circuits. So another example why split load boards should be thrown in the bloody bin.
Yep, and they should have gone and been years ago when solar was first being put in. The main problem with this is that if you've got that arrangement where you've got, say, 6 circuits, one of which is the solar, and it's all on the same thing, RCD trips, but it doesn't disconnect until the inverter shuts down, which, depending on the type, could be many seconds rather than milliseconds. So 4 or 5 seconds later, it might shut off, and for that time, all your other circuits are still powered. So definitely not something you want.
I remember talking to Mr. Scum about this. You remember when we were at LX and we had the stand and we had the wall of wants?
Yes.
Yeah. He drew this out and he did the AFDD with us, and then he did this and he said about 415.1 RCD additional protection. You shouldn't put them with inverter on the load side because they will not achieve disconnection within 40 milliseconds because the inverter will not disconnect within that time frame. He said it then. And that was going back to the feed-in tariff days. And I remember, I think Warren Matters, Mike Peace may have wrote an article. He hasn't said that it takes too long, but he has recognized that it can take longer than the requirements of 415.1 needs. And again, a reason not to put the feed from a generator onto the load side of a protected RCD circuit. But that was back then at the, when we had that thing. That's when Mr. Scone was telling me about this.
A while ago.
John
57, stationary batteries.
Yeah, chapter 57. This chapter provides requirements for stationary secondary battery installations where the design purpose is for storage and supply of electrical installations. This is all new. It's 4 pages in length. And really, this is just sort of catching up with what's already being installed because, of course, batteries are going in everywhere. People's houses, offices, out in the middle of fields to power the grid when there's some kind of problem. So certainly should have been in there already, really. But
it is quite an interesting one, this one, because I did have a quick read through it, and it talks about warning notices if the maximum supply is going above 100 amp. So if you've got battery capacity, there's a whole debate, and it's a separate podcast in itself about where you've got all this additional generation capability and overloading the main switch. And are we going to have boards with 125 amp main switches in? Diversity not being used for load control. So there is quite a lot of complex stuff that I think over the next 10 years will consistently, like the code of practice for EV chargers and battery storage, every couple of years change because our knowledge of this is coming out. And we will do one on solar PV as well, where we'll talk about that, but we won't go into that. The only thing we will say though is within part 57 there is reference to batteries must be installed with in accordance with PAS 63100, which is free from BSI. And in a nutshell, what it says is what everybody with a brain has been saying: don't put batteries in lofts. Simple, really. If I ever have batteries, they will go in my shed at the bottom of my garden. That's where they will go, because if they catch fire, they can catch fire out there. They're not burning my house down. It also doesn't include batteries that form part of emergency lighting, fire alarm panels, product batteries, alarm systems, machinery batteries, or pluggable UPS batteries. So that's not covered in that, but because they're separate product stands and stuff. Moving on to part 6. Here we go, chugging through. 3 more bits to go. Part 6, 6531. Upon completion of the periodic inspection and testing of an installation, a condition report based on the model given in Appendix 6 shall be produced, and a little new section saying taking account of the notes, which I believe have been completely rewritten, John, producing a report providing Appendix 6.
Yeah, they've basically rewritten all the notes, and now obviously you should take account of them. So nothing too surprising.
Everybody have a read. 6532, the report shall include the following, and Part G says guidance for the recipient or recipients based on the model in Appendix 6, and then a note, which is a beautiful thing that fills me with joy and also petrifies David.
Yeah.
Which says photographic and or thermographic. So first mention the thermographic, which, by the way, thermographic isn't defined in Appendix 2, Part 2. Another small gap. Images can be appended to the report to support observations made. Dave, monologue away.
Yeah, I mean, this has been in Guidance Notes 3 for a while, the example of thermographic imaging. And I understand that it's a great tool to support observations. The problem, well, not really a problem, the concern I have is the competency of people doing this. And I've been to a talk, I've been to one of the CEF guy talks, and they were promoting a very small orange camera by one of the things, and it's basically a 250 or 300-pound camera. Those are things that for looking at things that are hot, things that are cold. You know, we call this qualitative analysis. If we're going to start taking actual measurements of new numbers and data, we want to do quantitative analysis. We need higher resolution images, and we need competency and training. So my concern here is if we are going to start kind of just saying, yeah, let's bring thermographic imaging into these things, we need to make sure that we're doing it correctly. And I can just see myself in the future, and I've gone to so many businesses, oh, we have a company doing our thermal, I look at it and it's out of focus, it's obscure, the pixels are huge, or I'm looking at the actual image, the guy taking the image, I'm looking at his reflection. So I just have a bit of a concern that we're just going to start grabbing a camera, putting pictures in, and getting more people doing this work who aren't competent to do it. And doing a one-day training on how to do a thermography is not thermography training. There's an ISO standard, there's a PCN level 1, level 2, level 3. Level 1, taking an image, level 2, doing a review and a report on an image, and there's an individual third-party certification structure for an internationally recognized system. That's the thermography industry, not buying a camera and taking the picture and putting it on an EICR. That's my concern. I'll stop.
Good monologue. Well done. Thank you very much. That's kind of all we were going to cover on part 6, really. It's not like Amendment 2. Right, part 7. I'm going to start off with the Eddie Clements regulation. Obviously, there's 701, 702, bath or showers, swimming pools. Eddie, God bless him. Everybody knows Eddie Clements. He kindly produced during COVID the CPD calendar. He's been on every single podcast and live YouTube thing known to man. I've shared an Airbnb with him. I've shared some wonderful diverted neutral current experience with him. He's a very caring, sharing, and giving man. He literally lives the value of he just wants to do his bit and help anyone and anything, and he's a good lad. These are from Eddie. These are some examples of obviously what we're going to cover in a second. The old I always assumed baptism, when you were baptizing people in religious fonts and all that sort of stuff, that it would be, you know, you dip your head in a little bowl of water. But look at these now. They've got these little walk-in. It's like when you're cleaning your feet when you're going in a pool, but it's, you know, deep enough for you to be baptized in. And naturally, there are switches near to it, and there are heaters. And by the way, Eddie has sent me pictures of him measuring the distance of sockets and switches from said area. So he's incredibly thorough. Please find him on Instagram and LinkedIn and everything else. So we thank him for these pictures. But going into 701, the scope, the term birthing pool has been removed. And 702.11, scope has D, pools for religious and or ceremonial purposes. That's now been included because a lot of them have heaters in them or around them. So the particular requirements also apply to the surrounding zones of these basins. These requirements may also be applied to the installation of hot tubs outdoors. So that's good. Hot tubs getting some more coverage. In addition, wet, barefoot persons may perceive an electric shock from voltages imported via the pen conductor when in contact with earth and accessible conductive parts. It's a worrying statement to put in there. You might feel a tingle. Hi, DNO. What are you doing? What was that? Silence?
It's so true, though, isn't it? That's the problem. When we've not got our footwear, 10
ohms.
We've not got our footwear on, and we're wet. Those volts that are in that ground all the time suddenly hurt.
Dave, hang on. I've just been told. Call back when it's above 100 volts, and it goes below 20 ohms. Okay, thanks. Cheers, thanks.
So not so wet or not so heavy on the ground with your larger feet. Then
mildly wet. Mildly wet.
Mildly wet. Okay.
Sort of damp and humid.
So you at your hot tub, but not on a rainy day, then you're okay.
Yes,
All
a
right.
rather moist day. In these areas, in normal use, the risk of electric shock is increased by a reduction in body resistance and the contact of body with earth potential. Swimming pools within the scope of an equipment standard are outside the scope of these regulations, except for areas especially designated as swimming pools. The requirements of this section do not apply to natural waters, lakes and gravel pits, coastal areas and like. I know Eddie's campaigned for this for years.
Yeah.
Eddie does a lot.
Well, he works in churches pretty much all the time, doesn't he?
Eddie, for those who don't know, he will go to a church. He will be the man who rebuilds the heating system. He does it for Jesus. Well, he probably doesn't actually does it for money, but he does it for the right reasons. I have been privileged to spend some time with him on them. The man builds his own panels. He does a phenomenal job. He's incredibly knowledgeable and he's a nice guy. So thank you for that one, Eddie. Right, moving on. Oh, agricultural and horticultural premises, 705-4114 TN system. A TNC system should not be used, has been deleted, which is interesting. It then goes on to say, new part, a pen conductor shall not be used within electrical installations of agricultural and horticultural premises. When do we use a pen conductor exactly? Exclusively?
Well, pretty much never.
Yeah.
And it's kind of the same thing, because a TNC would have pen conductors throughout the installation, but as you can't generally use TNC in the UK anyway, it's sort of just rewording it in a somewhat different way. But
it's
when
the
are we
same
going
kind
to
of
get
intent, isn't it?
When are we going to get to the point where we actually admit that TNCS is actually a potentially dangerous supply, given the age of the infrastructure? Because we really do need to. We really do. I mean, what's it going to take? Like loads of people to die? More diverted neutral current issues? Or are we just going to like gently tiptoe around the fact that the DNOs are not being as publicly transparent as they should be? Oh, did I say it out loud? Damn it. Sorry. Not that I haven't tried, and they know that. Right, 708 camping and caravan parks. So they've deleted a note for installation in caravan parks which are operated at 12 volts. BSEN 1648 1 and 2 apply, and then for installation in caravan parks which are operated at voltages other than 12 volts, section 721 applies. 708 again, the means of connection between a caravan pitch and leisure accommodation vehicles should be an assembly of the following, and there's a new part and section B on this regulation. A flexible cable of continuous length, 25 meters plus or minus 2, having a harmonized code designation of HO5VVF, BSEN 50121-211, or HO7RNF to BSEN 50525-221, just rolls off the tongue this, or
Lovely.
equivalent, incorporating a protective conductor with conductors to be identified according to Table 51, the cross-section area in accordance with Table 721, and an outer sheath coloured orange.
yeah, the orange bit is the main thing, because previously they quite often ended up being blue, but now they have to be orange.
Well, it makes sense on a caravan
Yep.
park. Orange is bright. It's
trailing through the grass. So
yep, it's a very good. I actually completely agree with that. To be honest with you, HO5 and HO7 good. As long if it said SY Flex, then I'd be incredibly worried. But I'm sure those who are doing EICRs on caravan parks were probably expecting more, but small steps, as they say. Let's see. Right, here we go. John 709.
yeah, this is marinas and similar locations, and essentially there's not a huge amount of change here. Basically, figures 7091 and 7092, which are examples of methods of connecting to a supply, is gone, and they've got a new annex which has got the diagrams or similar diagrams in it. And then the other addition is 709-3131-101, which is where a fixed onshore isolation transformer is used to prevent galvanic current circulating between the hull of the vessel and metallic parts on the shore side. Equipment complying with BSEN 6155-824 shall be used, and the protective conductor of the supply to the isolated transformer shall not be connected to the earth terminal in the socket outlet supplying the vessel. It should be pretty obvious, because if you've got an isolated transformer, the whole point is you don't want to connect it to the protective conductor of the supply, because otherwise it's not an isolated transformer anymore. So
Yeah,
fairly common sense stuff, really. And so the diagrams have been revised and moved into their own annex rather than in just the couple of diagrams they had in there previously.
710 medical locations. Now this is a fascinating one because I've spent a lot of time actually many years ago, well over the years, discussing this with peers at the IET and whether it's right and whether it meets the their own standards. But basically, it's 19 pages long. Most of it's been completely rewritten. There's a new annex with a record schedule for supplementary bonding. Ironically, it looks like one that I used in Excel 20 years ago. And I'm really pleased to see it because there's no reason why people can't use that as best practice to record their bonding test results. I think we need more. I've seen a lot of medical locations recently on social media. I think it is an ism. Medical locations is an ism. When you think about the resilience they need of power supplies, the criticality of power supplies, medical locations, effectively hospitals, you have to have power regardless. People will die potentially. You've got to have backups, and it's got to be well maintained, well configured. So I haven't read all of it, but I think that's probably got to be a separate podcast. If anyone works in medical locations and they're still awake, please get in touch. Maybe we can talk about this on a podcast at some point when you're ready. No rush. John 712.
Yeah, 712 is PV or solar photovoltaic power supply systems. Whole pile of stuff's been deleted here. 71244 was previously protection against voltage disturbances and electromagnetic disturbances. Basically, all the voltage disturbances bit has been taken away, so it's now just protection against electromagnetic disturbances. And then the parts about protection against voltages, voltages of atmospheric origin and transient O voltages have been deleted. So it is just literally a one-sentence thing.
So has, like we saw in 444, has just over voltage disappeared?
So that's weird because I've got surge protection DC on my strings.
Yeah.
And that's because it came from the BSCN standard. And now it's been deleted.
There must be something. There must be something.
There is. I can tell you now because we're going to do a podcast on this very soon. Solar PV manufacturers, I smell an influence here because they have consistently said, yeah, you don't need isolators, you don't need this. Once you switch it off, you can just unplug and away you go. Our devices do everything. It's quite interesting. All I'm going to use, I'm just going to throw a little bone, a little teaser. I'm just going to say the word PID.
PID.
And maybe at some point we might want to say something a little bit more controversial in another podcast in the future, but we'll move on. Just to be clear, I'm ignoring that. I will continue to have surge protection on mine. Thank you very much, solar manufacturers, but the tail does not wag the dog in this case. All right, so let's move on, speed up a bit. 714 outdoor lighting installations. This is an interesting one, this one, for any lighting professionals. They've amended the note, or put a new note in, sorry. While some installations may be excluded from outdoor lighting, because there's a list, this section shall still apply to installations which come under the definition of highway power supplies or street furniture, for instance, road traffic signal systems. So a bit more clarity on this applied scope, but we know there's been incidents where people have been killed, and obviously there's more additional protection. So 714-41134, lighting that is accessible to the public shall have an additional protection by an RCD, which is a current reg, but they've added having a rated residual operating current as specified in regulation 41511. The examples have now been deleted in that regulation, but two notes have been put in. One that says lighting includes luminaires, control equipment and wiring. Don't really know why to define that, but okay. And then note 2, lighting is considered to be inaccessible if live conductors or equipment are out of reach or located within a locked or secure enclosure or housing having a minimum impact rating of IK08. So question 1, who came up with IK08? Because I could probably smash that. 2, I think that note is quite dangerous because you can argue if it's a lighting column and it's locked away, it's a reasonable assumption. Okay, I can go down to the lighting column at the end of my road, just tap it, and the door will fall off. So I'm a bit miffed. I think this gives more flexibility for RCD usage. My opinion is RCD all lighting that the public can touch, with the exception of an installation that is under control, like a 7909 temporary event, or a building that has 24/7 maintenance, electricians, PPM regimes, stuff like that, that's reasonably foreseeable to be controlled. What do you think, guys?
That seems fair.
Yeah. I mean, the problem I got with that bottom one, the Note 2, is that it's always saying it's inaccessible if it's in a locked cabinet. But what if there was some problem with it and a fault occurred and that metal cabinet became live? So someone could still touch that and get a shock and be killed by it. So why not just put an RCD on anyway? The fact it's in a locked cupboard might secure the conductors away, but if the enclosure is metallic, then that's not really a protection against anything. It's no different from a lighting fixture that might have just had a metal outside and someone could grab hold of it and get a shock from that. So just put the RCD on it in the first place.
Yes. Part 7. So 716 power over Ethernet is brand new. Is it exciting? Are we excited by this?
Well, it's new in terms of it being put in BS7671, but power over Ethernet is not particularly new itself. It's existed for a long time.
Well, I'm going to go into smug mode again and say that a certain group of chaps many, many years ago, in fact, the last decade, did a presentation where a certain Mr. Watts very succinctly predicted the whole, you're just going to run a Cat 6 and you're going to run your TV off of it. But this is a whole new section, 7161. The scope is the particular requirements of this section apply to the distribution of extra low voltage DC power using balanced information technology cables and accessories, primarily designed for data transmission as specified in BSEN 50173-1, using power feeding sourcing equipment in accordance with BSEN 62368-3. Now, there's lots of requirements in this as far as power over Ethernet. There's maximum lengths of cable, there's volt drop, there's all sorts of stuff to consider. John, I think you were mentioning last night there was additional stuff as well in regards to how much power.
Yeah, there's several standards there. So in the lowest one, I think it starts about 30 watts, but one of them actually can go up to 100 watts per port or something like 72 watts per device, which is
TV. It's TV power now, isn't it? That is TV power. That is TV power, and that's what we picked up. The other thing to add to this is this will help branch or support the energy efficiency challenge. If we generate DC, we store DC, and we utilize DC, there are no losses because there's no transferring. So in the longer journey, that is probably where this is going to go to.
Wait a minute, Dave. Are you suggesting that this could do what you predicted it would do years ago?
Well, if it can, it will, and this will.
Well, it's quite interesting. So 7161, the scope requirements are included for design, erection, and verification, telecommunications infrastructure for the purpose of both telecoms and distribution of ELV DC power feeding. In addition, requirements are included for the use of existing telecoms infrastructure and distribution of ELV DC power. The power delivery systems include, but are not restricted to, the power over Ethernet system specified by IEEE 8023. I found an error straight away. It clearly says design, erection, and verification. Okay, so I'm not too keen on the word erection because let's be honest about it, what's the biggest problem we've got in industry?
Yeah.
Telecoms engineers. So I know erection means installation, but how about inspection, testing, and verification? How about expanding that definition so they can't get off the hook with doing lash ups, is what I mean. Interestingly enough, one of the other little gems from it, 716-523-1101, DC current carrying capacity of any conductor temperature up to 60 degrees, these cables. So that's interesting. So we're now going to have to look at temperature rise of the data cables due to the load that they carry, and then any attenuation, losses of the cables, performance of them, whether they're bunched. Oof.
Yeah, and data cables are always bunched together, aren't they? I mean, there's like, oh, here's 300 of them coming through.
Yeah. or their cable spaghetti. But again, that's a significantly different use than PoE potentially would be if we were going to power. I mean, the past few years we've been using it for like CCTVs and for cameras and little bits of motors, but we're talking now. This is tipping into quite a bit of power. Interesting that it's IEEE. I like that. I could just see Paul going, "Whoa!" in the corner, Mr. Skyrme. Yeah. We get IET and the IEEE kind of working in this kind of fashion. So that's interesting.
It is, yeah, it is definitely interesting. 722, I think it's the most changed part of any of the special occasions. You could translate that as we're kind of making it up as we go along. 722 42117, AFDDs are not required for circuits supplying electric vehicle charging equipment with socket outlets or vehicle connectors conforming to BSEN 62196-2. Note, AFDDs can be used, why not contradict yourselves, in conjunction with the charging equipment if required by the manufacturer instructions. Now, John, what do you think? Because I know yeah.
Well, yeah, I mean, you wouldn't generally want to put an AFDD there anyway, but in theory, if the charging manufacturer or equipment manufacturer said, yeah, you need to have one, you would put one there, but no manufacturers are doing that, because why would they?
Why? Yeah.
I mean, what's the point? So it does seem somewhat pointless putting all of this together here, but nevertheless, they're not required, but unless, of course, they are.
I can only assume it's in reply to requests for clarity on that. I mean, I don't know why people would be putting them on. It seems to be obvious to just not touch
the
them with
amount of
AFDDs.
electronics that are going into these EV socket outlets now and smart stuff and curtailment, what's to say that these AFDD microprocessors won't, one, give you lots of false trip outs, and two, actually not have that, what's that, mutual detrimental interference?
Yeah.
Well, one processor versus another processor in series.
Did you see that video that Dave Savory had? It's a really interesting video. I got sent a link and I watched it. He has a test board made with all these different manufacturer AFDDs, and he puts a normal load for them to operate under 62606, and they operate individually nice and fine. He then turns the fan heating off and turns the fan on, the fan only, so the load runs under the limit of 62606, under 2.5. And whilst the AFDD that the circuit is on is thinking about what to do, the EMI interference, and Julian from Chauvin Arnoux went to verify this, trips a neighboring AFDD that's doing jack shit, and actually operate an AFDD on the opposite wall of another board. So, this goes back. Remember that old video of the two-way radio tripping an RCBO?
Yes.
This situation.
EMI is a real thing. EMI is a real thing.
And it's a really interesting video to watch. And he's got all these AFDDs, different manufacturers, and he puts the current to a lower value that shouldn't operate the AFDD. And whilst it's thinking about it, because he is arcing it, but very low, whilst the thinking power in the AFDD is operating, the other AFDDs mind their own business, are tripping off. So yeah,
I will watch that one. I kind of equate Dave Savory to the critical drinker, if anyone watches him on YouTube. He's the critical drinker of the electrical industry. Yeah. Vastly intelligent and smart man, and loves a drink and just says it as it is. But yeah, I will watch that one. I've not seen that, to be honest with you. I don't watch YouTubers in general, but I will. I will go and find that one. Right, next one, moving on quickly. Heating cables and embedded heating systems. So external influences, 7535122. Heating units for installations in ceiling shall have a degree of protection not less of IPX1. Really? Heating units for installation of floor concrete material shall have an ingress protection of not less than IPX7 and shall have the appropriate mechanical properties. I'm worried that we're even having to write that sort of stuff.
Yeah, I mean, you'd think it was common sense, wouldn't you? And it would already be there, but it isn't. But anyway,
there it is.
So.
There's a great regulation, 7535141. Currently says the designer of the installation heating system or installer should provide sufficient documentation. It's extended that says which shows the layout of the heating units and the information relevant for the maintenance. Again, common goddamn sense. It's embarrassing that's having going, but hey, leave it. That's a good sentence. Right, part 8. Now, drum roll for the big finale. So we had our predictions on this and we failed. However, we have new predictions. So part 8, chapter 81, energy efficiency. We all know that we've said before, chapter 17, appendix 17, energy efficiency, will eventually work its way into chapter 81. Because it makes sense with the 60364 standards, part 8-1-2-3. We've always naturally assumed that, and I still say to this day that will happen. Yeah. However, John, well, you tell your story of what you found of it.
Yeah, I mean, chapter 81 should be all of what was in the appendix and a pile of other stuff. But for reasons the Chapter 81 they've put in here in this particular document has basically nothing in it. All it's got is a couple of sentences stating you should refer to things like approved document L, the domestic technical handbook, and various other bits, and that's it. So it's literally just a few sentences, and as we'll see, the actual appendix with all the stuff that was in it has been totally destroyed and deleted. So at the moment, all we've got is just basically have a look in a couple of approved documents and some technical booklets, and there is a reference to 603.64.8.1, which is what should have been in here, but for whatever reason, they've not put it here.
I think we've missed the opportunity, but I will say this will come back, because we're on that net zero. It's inevitable. The government are going to put pressure. This will come back. And I know the IET on the webinar said there are separate books and IET guidance. So there's the Code of Practice for battery storage. There's the Designer's Guide to Energy Efficiency. But I still think at some point the government are going to say there's not enough traction. Someone is going to sit in a committee and go, why is it not in the wine regs? And then eventually they're going to go, we need to get this back in, and then it'll appear again.
It was in the blue public draft, and we all commented to have it out.
Yep.
But it was in there, and it's in 603.64. It will come back.
Well, we always believe that energy efficiency is not an electrician's job, and I agree with that. However, electricians going forward with smart, connected, bidirectional, local producing, storing, and consumption, we have to change what an electrician is. We have to think not in a linear, but in a multi-directional way. And that involves, unfortunately, the energy efficiency installation. Because if you're not going to think of that, what other parts of the installation do you not think of? I know it's controversial, apologies, but the reasoning and logic given in the IET was about politics, new government uncertainty, what the policies are going to be for net zero. Is it actually practical? Obviously, will or is it published as separate guidance, which we know the IET books is. And obviously, Appendix 17 has been completely removed, and that was just 6 pages of text, which is like an abridged 603.64.8.1. Moving on, nearly there. Appendices. Now, we've just picked a few of these. I did expect Chapter 83 to appear, but hey, let's leave it for the 19th edition or Amendment 5. Appendix 4, current carrying capacity and volt drop. So there's some amended figures here. I've just screenshotted the table very simply. So one of the simple ones is, rather than just having buried cables, they've now got buried in ducts, which changes current carrying capacities to a certain extent, as you can see there, dependent on depth of laying, ground conditions, temperature. It all links into other standards from cable manufacturers. It's quite interesting.
Haven't they just swapped the columns round?
In buried ducts. No, I thought that, but they said on the webinar it had changed because of the method. I don't know whether that's worded correctly, but on the webinar they said that it was cables were buried and they've now gone into buried ducts. But you are right, because the deleted text has that as well. But these are apparently additional columns, so I'm only going on what I've seen in the current carrying capacity table and what was on the IET webinar. But buried direct in buried ducts is now in buried direct in buried ducts and buried direct. It's like they flipped them.
They just swapped the columns round.
I think they have.
Yeah.
Possibly, yes, they have. They've swapped them round.
Huh?
Yeah, they have actually. Yeah, you're right.
They've labelled buried ducts D1. They've made and buried direct D2. And because they've had to label them that way, they've swapped them over. Just
for everyone listening, it is midnight, by the way, and we are tired, so we're getting to the end of this. So apologies, but yes, they've swapped the columns round. But on the webinar, they did say that they had gone from cables buried into buried ducts. So
again, in the large scale EV, I have this issue because they use the ERA calculations. They abandoned 7671. The cable calculation data, you get an awful lot more cable current carrying capability for a conductor that's buried directly than one that's buried in a duct.
Well, it's like earth loop impedances, though. Once you go to the manufacturers of the device, you get more tolerance on the earth loops.
They just abandoned 7671.
Yeah, they do. Yeah, because it's an average of them all. Okay, so that's one to look at. Model forms, Appendix 6. Quite interestingly, we all love our codes, C1, C2, C3, FI. Section E, John.
Yeah, the main change with this is that FI is now not something which is going to cause it to be unsatisfactory. So as we've now got basically fail is going to be C1, C2, and not fail is C3 and FI. And they've actually, on the model form, they've split it up into 2 individual sections. So your C1s and C2s go in one bit, and the C3s and FIs go in another one. Bit of a strange choice, really, but it also depends on what you're going to put FI against, because some things that need further investigation could be potentially dangerous, but others might not be. So
again, so are they saying an FI alone is not suitable to be unsatisfactory?
Yeah.
Even if the FI
they're not saying that. So just to be
potentially
clear, Dave, they're
troublesome
not
FI.
saying that, but what they are saying is C1 and C2 is what is unsatisfactory, which by default makes C3 and FI the satisfactory, if that makes sense. So if you've got them, you can still pass it. Let's be perfectly frank here. To everyone listening, this needs rewording. This needs a little bit more work to give more clarity. I also think this is going to create carnage. I personally, I'm going to put it out there. I think we should bring back C4. Shake things up.
I think
You think about what was C4 code? C4 code doesn't comply with 7671. Put it back, because how many installations, and this is my argument, how many installations are failing, okay, based on it doesn't comply with the regs now, but it did comply with the regs at the time. If you put C4 instead of FI, they can list off all the non-compliances to the current regs, but it doesn't make it fucking fail. That makes it a fair game use then, doesn't it? So it's either requires improvement or just fundamentally doesn't comply. And if it's dangerous or potentially dangerous, it clearly splits the two.
Yeah.
So my recommendation is go back to C4.
I think one of the points I think that they said was the reasons the schedule of inspections has kind of been like generalized as well is to try to minimize the amount of information. And I think that's one of the reasons why the code 4 went, was because you'd have EICRs or periodic inspections and
but you're always going to do that.
But Dave, I agree with you, though. I agree with you.
Imagine you had an installation designed to the 15th. It was not non-compliant at the time. If you can at least separate the current assessment to standards against what was, you get a fairer.
The problem with that is if you've got some electricians that are new and fresh, don't understand what the regulations were in the 15th. Because I agree. I mean, if I find something now that would be, potentially a C2 today, but in 1992 it was acceptable. Now, how has that become potentially dangerous?
How many installs now are getting C2s for wrong RCDs and no RCDs? When I was learning when I was training, it was supplementary protection, and you would never ever code an RCD not being there as a failure of the installation.
It depends on for me that is always down to the utilization behavior. If it's the same person using it the same way with the same equipment, then there's no need for it. But if I find that there's new people, more equipment, extension leads galore, anything like that, if it's, again, this is why the inspector needs the freedom to actually make an inspector decision.
Yeah, I agree.
Instead of being locked into this, and that.
Oh, okay.
That's a lot. That's a lot of words.
There's a lot of words there. So Appendix 13, escape routes and fire protection. So I'm going to do a Dan Jackson and say it's a mess. It's a bit of a mess, really. Dan has read this. There are 2 points at which occupants should be able to achieve in any given fire scenario. Means of escape is means of escape by which safe escape to a place of safety is provided. So they've introduced these terms in 7671 that I think are going to cause a lot of questions. Point of relative safety is somewhere where that is protected from fire, but it should only be used for a limited period of time. This is the entire appendix, by the way. This is new. This is usually defined as a protected stair or firefighting shaft, which includes a firefighting lobby and a firefighting stair. The fire safety provisions are specified in approved document B. Again, we're taking stuff out of laws. BS 9991 and 9999, but again, no 9992. So, dear rail industry, come on, get to the table. Number 2, point of ultimate safety is a place. So you've got point of relative safety and a point of ultimate safety, which is a place away from the premises in which people are at no immediate danger from the effects of fire. It then goes into fire safety measures, a lot of fire engineering stuff, building construction, processes, specifications, how you can achieve it by using metal, tray, fire rated fixings, all that sort of stuff. I think there's a lot more needs to be done to tell electricians what they need to know and what the fire
Yeah.
engineer needs to do.
This is the thing here. There's a risk here that we're trying to train or train electricians to understand a bit, but not enough. Either they need to understand it a lot more fully, or they need to just communicate with the building manager to say, who am I talking to make these decisions for me or to help me? We're kind of halfway here. We need to not give them so much that they think they know enough.
Dave, it says at the bottom where other cables are installed, apart from being low smoke and zero halogen, to BS specifications. What's a BS specification? I thought they were standards. I'm a bit miffed by that. I didn't think in cable standards were specs, but maybe wrong. They should protect the occupants within the firefighting shaft and protected enclosure. In these circumstances, a membrane ceiling should be constructed which has 30 minutes fire resistance for integrity and insulation. 30 minutes. Okay, yes, that is absolutely 30 minutes. You can get 30, 60, 90, 120. Substations are normally 240 minutes. So the minutes is about how long it can resist the fire to enable escape. I'm not comfortable with this, and Dan certainly isn't comfortable. I think this needs to be clearly split as to what the fire engineer's duty under the building regulations are and the standards, and what the electrician's duty is.
I agree.
And until that's done, I don't think this will be right. Again, and that's it. We're done.
Oh, concluded.
We are done at a whopping, God knows how long we've been going for, but the timer says we've been talking for 4.5 hours, but we've probably only been recording for 2.5. So let's be perfectly frank, John, you've been looking at this. Dave, you've been looking at this. There is loads more.
Yeah, I mean, I've had a brief look through. I mean, I have to say congratulations and thanks to you two, because I've really had no time this week.
Thanks to John, actually.
Thank you, John. Now we're looking obviously towards 2026, but there's definitely going to be some tweaks and changes. Now, with 2018, we had the draft. It came in, and there was lots of changes to the draft, but then the changes there was no other announcement. They just landed in the book, didn't they?
Yes.
In the final version. And
they snuck some bits in.
And is that what would happen here? There won't be another commentary opportunity. It's this.
No,
and if they scrap bits, add bits, do bits, change bits, we won't know until the book.
But that's how they get stuff through, Dave. They do the DPC. If they change stuff and do some other bits, in theory, they should be held accountable. If they change something that wasn't in the DPC, in theory, it should go back to DPC or be withheld to the next DPC.
There's a lot that can change between now when this is published.
A hell of a lot.
Yeah.
A hell of a lot.
And there's a lot that needs to change as well from some of the bits we've seen. But I say, unfortunately, the process is it's reviewed, and once the comments are finished, it disappears into the various people that deal with it. And the next thing everyone else gets is, oh, here's a new book.
Here's a new book. And here's some new guidance books to go with this new book. And here's a new regulation course to go with this book.
So, and there is going to be new books, new guidance notes, new city and guilds, new all sorts.
Yeah. It's just a machine. I do get concerned with how much time we spend on 7671 and how much the industry just focuses and looks at. It's like just everyone looking at this one book, and there's so many more things we should look into.
Yeah.
But we draw so much attention to this one book, and this is just carrying on this practice.
I don't disagree. I think final thoughts. What do you think to this amendment for DPC, John?
There's some good stuff in it. There's also some absolute shambles, like the fire stuff, for example. I think the main thing is that this is the only time anyone's going to get to comment on it. So, for goodness sake, go and register on the site, which is free. Go and actually read it all. Put some comments in. Because if you don't, then that's it. You're not going to get another opportunity.
No.
Dave, final thoughts, mate?
Oh gosh, there's I mean, the rewrite of 710. I need to have a deeper look at that and see. The power over Ethernet, good. We kind of knew that was coming as well. The over voltage has kind of puzzled me. I'm confused. I'm not sure what the next thing would be. I want to look more into that as to why they've done with that and why they've acted that way on it. Because it's nice to do something, but I'd like to then see what the alternative, what the new is, and it doesn't appear to be here. But no, I think that there'll be an awful lot of differences. Again, I think that 60364-81 should just be in here. We're going to be pushed heavily towards energy efficiency, sustainability, especially as we're going into the renewables and all this stuff. There's going to be so many buzzwords about all this, wanting our designs to, technically you can have two guys do two designs, and whilst we may look at economics as the prime driver, in 3 or 4 years, the other driver may be energy efficiency or sustainability in an awful lot of projects. And so I can see the IT publishing a few more books on this, to be fair. I do have the energy efficiency one, and it is a bit dated, to be fair. So that's probably ready to be launching.
Yeah.
I think between now and publication, though, will do some more time looking at what the buzzwords are, what's going on, and we'll return to this draft to see what we think is going to tweak for it, because there's going to be tweaks to this.
Yeah, I mean, I know NAPIT, NIC, lots of other industry bodies are going to do more in this ECA. So well worth watching what their views and opinions. And again, that's what this has been. For my personal opinion, I think there's some good stuff. I think there's some absolutely shocking stuff in it. I think some of the errors that they've put out are just appears very, very rushed.
Yes.
If you're watching and you're not happy with the quality of what we've done today, please note we've had 48 hours to read all of this and prepare it, and we're all incredibly busy working. So feel free, if you want to do your own one, please do. That's the whole point of these debate pieces. Until then, we will be back because we've got more unspoken of things to discuss and explore. And we've also got to do one where we get all the gang back together to speak about Mr. Skyrme and bring in Mr. Betteridge to talk about his stuff. So we have a few more of these to do. When we do them, we don't know, because we may be back in a week, we may be back in a month, we may be back in a year, who knows. We may do another one of these before the end of the DPC once our understanding has grown on this. We may not. Who knows, as is life. But until then, it's really, really late. Thank you very much for listening. Thank you very much for watching. And until the next time, take care of yourself and each other. Bye-bye.
Bye.
Bye-bye.
No more swearing, Mr. Ward.
Paul, I'm going to shoot. I've got to shoot for a bit. Do you want to text me when we jump in?
That's exactly what I was planning to do. But yeah, so you've joined and now you're leaving. So
Yeah.
I've got to go say nice to the kids as well.
that's fine. Go do your
Wife's
stuff, man.
shouting at them at the moment, so
It's fine.
she needs backup. I'll back in 2
Yeah, fine.
minutes.
Go for it.
All right. See you in a bit.
Okay.
John appears to be really kind of ahead with all of this. He's well, not surprised, to be fair.
John Ward is
Yeah.
the only electrician in the country who is qualified to the 27th edition Amendment
And his
62.
customers don't appreciate it.
And they don't appreciate it.
But they should know.
I don't appreciate. No, I don't even know what it is, to be honest with you. But don't be surprised if we're on Amendment 12, 15, 20, 30. I can just see the 18th edition being for the rest of our careers now. Maybe that will help with regs fatigue. But anyway, let's do the usual.